Welcome to the world of business analytics, where data holds the key to unlocking success in the corporate realm. In this comprehensive video course, we will take you on a transformative journey, empowering you with the knowledge and skills to harness the immense power of business analytics tools. Whether you're a business professional seeking to make data-driven decisions or an aspiring analyst eager to dive into the world of data, this course is your gateway to becoming a master of business analytics tools. Together, we will navigate through a vast landscape of cutting-edge tools and explore their capabilities and functionalities. We will delve into popular platforms like Tableau, Power BI, and Google Analytics, unveiling their hidden gems and advanced features. But that's not all. We'll go beyond the basics, immersing ourselves into data visualizations, statistical analysis, predictive modeling, and data storytelling. We will uncover the secrets to extracting actionable insights from complex data sets, transforming raw numbers into strategic advantage. Are you ready to unleash the power of data and revolutionize your business strategies? Join us on this exhilarating journey as we demystify business analytic tools, equip you with real-world skills, and empower you to make data-driven decisions that drive success. Let's embark on this transformative adventure together. Having said that, if you're an aspiring business analyst looking for online training and certifications from prestigious universities and in collaboration with leading experts, then search no more. Simplilearn's postgraduate program in business analysis from Purdue University in collaboration with Amazon, Google, and Microsoft should be a right option. For more details, use the link in the description box below. With that in mind, over to our training experts.
It is no surprise that business analytics and business intelligence are two of the fastest growing markets in the world. Organizations today are generating data at a rapid rate. There is a need to use this business data and make smarter decisions. Companies are looking for methods and tools to turn business data into actionable insights. This is where business analytics and intelligence can help play a critical role. Business analytics is the process of collecting, analyzing, and drawing valuable conclusions from vast volumes of data available. It helps to improve business performance through fact-based decision making. On the other hand, business intelligence or BI is a technology that enables data preparation, data mining, data management, and data visualization. It allows you to analyze data with queries and create reports and dashboards with the help of charts and graphs to be used by business leaders. Business analytics and business intelligence together create capabilities for companies to compete in the market effectively. Consider this example. Suppose you sell homemade chocolates through an online store. Business intelligence provides meaningful insights into the past and current state of your business. BI tells you that sales of your milk chocolate have spiked up in Texas the past 2 weeks. So you decide to manufacture more milk chocolates to keep up with demand. Business analytics asks, why did sales of milk chocolate spike up in Texas? By scrutinizing your website data, you learned that most traffic has come from a post by a food blogger based in Texas who liked your milk chocolate. This insight helps you decide to send complimentary chocolates to a few other well-known food bloggers throughout the United States. Using cutting-edge business analytics and intelligence tools such as Microsoft Excel, SQL, Power BI, and Tableau can enhance customer experience, improve efficiency, conduct competitor analysis, and accelerate growth.
I have always been passionate about learning new things and improving my teaching skills. About 5 years ago, I realized that I have a gap in my knowledge, and to fill the gap, I needed to upskill myself. I chose Simplilearn as my upskilling partner because of its comprehensive curriculum and its connection with Purdue University. Hi, my name is Carlos Linares. I live in Lexington, in the state of Kentucky, in the United States. I am an assistant professor at Midway University, and I hold a PhD in management, human resources, and leadership. I decided to opt for the post-graduation program in business analysis from Simplilearn, which has helped me a lot in my professional and personal life. I have been teaching even before I moved to the United States 17 years ago. I tried to use Excel while teaching research classes, but since I only had the basic knowledge about it and other business intelligence tools, it was very difficult for me at the beginning. But after completing this class and learning how to use tools like Excel, Tableau, Power BI, Power Query properly, I feel like it has been a total game changer for me. Now I apply these skills everywhere, which has also helped me a lot in my yearly review. I submitted all my certificates to my university, and based on that, my university plans to develop a class focused on business analysis starting in fall 2023. And I am really excited. When I finally decided to go for an online program, I researched a lot. And finally, I chose Simplilearn. And I must say it has been a wonderful experience. You see how the business world is changing now? And skilling yourself is quite essential to keep up with the change. Everything works on numbers now. Data is more valuable and important than ever. So, I encourage you to keep learning and keep growing.
So currently I am on my MySQL workbench. Let me connect to the local instance. So I'll give my password. I'll click on OK. Alright. So this is my MySQL workbench query editor. So first we are going to learn subqueries. Let me give a comment and write subqueries. Alright. So first of all, let's understand what a subquery is. So a subquery is a query within another SQL query that is embedded within the where clause, from clause or having clause. So we'll explore a few scenarios where we can use subqueries. So for that, I'll be using my database, that is SQL_intro. So I'll write my command use SQL_intro. Now this database has a lot of tables. I'll be using the employees table that is present inside SQL_intro. Let me just expand this, and you can see here we have an employees table. So let me first show you the contents within this table. I'll write select star from employees. Let me execute it. Okay, you can see here we have the employee ID, employee name, age, gender, there's date of join, department, city and salary, and we have information for 20 employees. If I scroll down, you can see there are 20 employees present in our table. So let's say you want to find the employees whose salary is greater than the average salary. In such a scenario, you can use a subquery. So let me show you how to write a subquery. I'll write the select statement. In the select statement, I'll pass my column names that I want to display. So the column names I want are the employee name. Then I want the department of the employee and the salary of the employee. From my table name, that is employees. Next, I'll use a where condition where my salary should be greater than the average salary of all the employees. So I'll write salary greater than. After this, I'm going to write my subquery. So I'll give select average of salary from my table name, that is employees, and I'll close the bracket and give a semicolon. So what it does is, first it is going to find the average salary of all the employees that are present in our table. Once we get the average salary number, we'll use this where condition where salary is greater than the average salary number. So the inside subquery, let me run it first. If I run this gives you the average salary of all the employees, which is $75,350. Now I want to display all the employees who have salary greater than $75,350. So let's run our subquery. There you go. So there are 8 employees in our table who have a salary greater than the average salary of all the employees. Alright. Next, let's see another example. Suppose this time you want to find the employees whose salary is greater than John's salary. So we have one employee whose name is John. Let me run the table once again. Okay, if I scroll down, you see we have an employee as John. You see this? Our employee ID 116 is John and his salary is $67,000. I want to display all the employees whose salary is greater than John's salary. So basically all the employees who are earning more than $65,000, I want to print them. So let's see how to do it. I'll write select, I want the employee name, comma, the gender of the employee. I also want the department and salary. From my table name, that is employees, I'll write where salary is greater than, I'll start my opening bracket. Inside the bracket, I'm going to give my inner query, that is select salary from employees where the employee name is John. So within single quotations, I'll give John as my employee. I'll end with a semicolon. So let me first run my inner query. So this will give us the salary that John has, which is $67,000. Now I want the employees who are earning more than $67,000. So let's run our subquery. Okay, so you can see 12 rows returned, which means there are 12 employees in our table who are earning more than $67,000. You see here, all these employees have a salary greater than $67,000. Okay. Now, you can also use subqueries with two different tables. So suppose you want to display some information that are present in two different tables, you can use subqueries to do that. So for this example, we'll use a database that is called classic models. You can see the first database. So let me use this database called classic models. I'll write use classic models. Now this database was actually downloaded from the internet. There's a very nice website. I'll just show you the website name. So this is the website, that is mysqltutorial.org. You can see here they have very nice articles, blogs from where you can learn MySQL in detail. So we have downloaded the database, that is classic models, from this website. You see here they have a MySQL sample database. If you click on this, it will take you to the link where you can download the database. So they have this download link which says download MySQL sample database, and the name of the database is classic models. Alright, so we are going to use this classic models database throughout our demo session. If I expand the tables section, you can see there are a lot of tables that are present inside this classic models database. We have cricket, customers, there's employees, office, there's orders, order lines, and many more. So for our subquery, we'll be using two tables, that is order details and products table. First, let me show you the content that is present inside the products table first. If I run this, you see here it says 110 rows returned, which means there are 110 different products that are present in our table, which has the product code, the product name, product line. We have the product vendor, description, quantity in stock, buy price, MSRP. The other table we are going to use is order details, which has the details of all the orders. Let me show you the records order details tables has. Okay, so there are 1000 records present in this table. You have the order number, the product code, quantity ordered, price of each item. You have the order line number as well. Okay, now we want to know the product code, the product name, and the MSRP of the products whose price of each product is less than $100. For this scenario, we are going to use two different tables and we are going to write a subquery. Okay, so if you see here in the order details table, we have a column called price each. I want to display the product code, the product name, and the MSRP of the products which have a price of each product less than $100. So the way I'm going to do is, I'll write select product code, comma, product name. Now one thing to remember, that this product name is actually present inside our products table, and product code is present in both the tables, that is products and order details. Here you can see this is the product code column, comma, MSRP, which is present inside the products table again, from my table that is products, where I'll write product code. I'm going to use the in operator. Next, I'll write my inner query, that is select product code from my table order details, where my price of each product is less than $100. Let me run this. Okay, so you can see there are total 83 products in our table which have a price less than $100. You can see the price here. Okay. Now we learn another advanced concept in SQL which is known as stored procedures. I'll just give a comment saying stored procedure. Okay. So first let's understand what is a stored procedure. A stored procedure is an SQL code that you can save so that the code can be reused over and over again. So if you want to write a query over and over again, save it as a stored procedure and then call it to execute it. So in this example, I want to create a stored procedure that will return the list of players who have scored more than 6 goals in a tournament. So I have a database called SQL_IQ. These are a few databases that I have already created. So this database has a table called players. If I expand the tables option, you see we have a table called players, and you can see the columns player ID, the name of the player, the country to which the player belongs to, and the number of goals each player has scored in a particular tournament. So I'll write a stored procedure that will return the list of top players who have scored more than 6 goals in a tournament. So first of all, let me begin by using my SQL_IQ database. We'll run it. So now we are inside the SQL_IQ database. Let me select star from players to show the values that we have in the players table. You can see there are 6 players in our table. We have the player ID, the names of the players, the country to which these players belong to, and the goals they have scored. So I'll write a stored procedure. So the stored procedure syntax is something like this. It should start with a delimiter. Okay. In the delimiter, I'll write &&. Next, I'll write create procedure followed by the procedure name. Let's say I want to name my procedure as top_players. Next statement is begin. After begin, I'll write my select statement. I want to select the name of the player, the country, and the goals each player has scored from my table that is players, where I'll write goals is greater than 6. I'll give a semicolon. Then I'll end my procedure with a delimiter that was $. Next, I'll write delimiter and give a semicolon. Now the semicolon suggests this is a default delimiter. And there should be a space. Okay. Now let's run our stored procedure. There you go. So you have successfully created our stored procedure. Now the way to run a stored procedure is you need to use the call method and give the procedure name, that is top underscore players in our case, with brackets and a semicolon. Let's execute it. Okay, there is some problem here. So we made a mistake while creating a procedure. The name of the column is goals and not goal. Let me create that procedure again. Okay, it says the procedure top underscore player already exists. Let's just edit the procedure name. Instead of top player, we'll write it as top players, and similarly we'll edit here as well. Now let's create it again. Okay, now to call my procedure, I'll write call space followed by the procedure name, which is top underscore players. If I run this, you can see we have 2 players in our table who have scored more than 6 goals. So we consider them as the top players in a particular tournament. Alright. Now, there are other methods that you can use while creating a stored procedure. One of the methods is by using an in parameter. So when you define an in parameter inside a stored procedure, the calling program has to pass an argument to the stored procedure. So I'll give a comment, stored procedure using in parameter. Alright. So for this example, I'll create a procedure that will fetch or display the top records of employees based on their salaries. So we have a table in our SQL_IQ database which is called employee details. I'm going to use this table. You can see we have the name of the employee, the age, sex, then we have the date of join, city and salary. Using this table, I'll create a procedure that will fetch or display the top records of employees based on their salaries, and we'll use the in parameter. So let me show you how to do it. I'll write delimiter. This time I'm going to use /. I'll write create procedure followed by the procedure name. Let's say SP for stored procedure, sort by salary is the name of my procedure, and inside this procedure I'll give my parameter in. I'll create a variable var and assign a data type integer. Then I'll write begin followed by my select statement, where I'll select the name, age, salary from my table name, that is EMP details or employee details. I'm going to order this by salary descending, and I want to display limited number of records. So I'm using this limit keyword and my variable var, which I created here. I'll end my select statement. I'll end my stored procedure with /, and I'll go back to my default delimiter, that is semicolon. Alright. So let me run this. There should be a space here. Alright. So let's run this. Okay, you can see we have successfully created our second stored procedure, which is SP_sort by salary. Now you can also check whether the stored procedure was created or not. Here you have an option to see the stored procedures. Let me just refresh this, and you can see we have 3 stored procedures that we have created so far. One is SP_sort by salary, the other 2 were top_player and top_players. Okay, now let's call our stored procedure. I'll write call space followed by the stored procedure name, which is SP_sort by salary, and inside this I'll give my parameter, which was actually var, and this var we have used in limit. Let's say I want to display only the top 3 records of the employees who have the top 3 highest salaries. Okay, so let me run it. There you go. So Amy, Sarah and Jimmy were the top 3 employees who have the highest salary. So you saw how you could use the in parameter in a stored procedure. We created a variable, and that variable we used in our select statement, and we called our stored procedure and passed in that variable. Okay. Now, instead of a select statement inside a stored procedure, you can also use other statements, let's say update. So I'll create a stored procedure to update the salary of a particular employee. So in this procedure, instead of select statement, we'll use the update command. In this example, we'll use the in operator twice. So let me show you how to do it. I'll write my delimiter first, which is going to be /, then I'll write create procedure. My name of the procedure is going to be update salary, and inside the update salary name I'll write in, and then temp underscore name, which will be a temporary name variable, and the type I'll assign is varchar 20. I'll again use my in parameter. I'll write in. Next, my other variable would be new underscore salary, and the data type would be float. I'll write begin and write my update command or update statement. I'll write update table name, that is employee details, set salary equal to new underscore salary, where name is equal to my temporary variable, that is temp underscore name. So this is my update command, and I'll end the delimiter. Alright, so let's run this. Okay, we have successfully created our stored procedure. If I refresh this, you can see I have my stored procedure update underscore salary. Okay, now let's say, first of all, I'll display my records that are present inside employee underscore details table. Okay, so we have 6 rows of information. Let's say you want to update the salary of employee Jimmy, or let's say Mary, from 70,000 to let's say 72,000, or let's say 80,000. So I'll call my stored procedure, that is update underscore salary, and this time I'm going to pass in 2 parameters. The first parameter will be the employee name, and next with a comma I'll give my new salary that I want to. So my employee name, let's say, is Mary, and the salary I want to be updated is, let's say, $80,000. I'll give a semicolon and I'll run it. You can see it says 1 row affected. Now let's check our table once again. There you go. If you see this record, for Mary we have successfully updated the salary to $80,000. Now moving ahead, we learn to create a stored procedure using the out parameter. So I'll give a comment, stored procedure using out parameter. Okay, so suppose we want to get the count of total female employees. We will create total employees as an output parameter, and the data type would be an integer. The count of the female employees is assigned to the output variable, which is total underscore employees, using the into keyword. Let me show you how to write a stored procedure using the out parameter. So first I'll declare my delimiter to /. I'll write create procedure followed by the procedure name. It is going to be sp underscore count employees, and inside this I am going to give my out parameter and the variable name, that is total underscore EMPs, which is total employees, and the data type will be integer. Next I am going to write begin followed by my select statement, that is select. I want the count of total employees, and the output I am going to put into my new variable, that is total underscore EMPs. From my table, that is EMP underscore details, where sex is equal to F, which means female, I'll give a semicolon. Next I'll end it with the delimiter, and I'm going to change the delimiter to a default delimiter, that is colon. So let me tell you what I am doing here. I'm creating a new stored procedure, that is sp underscore count employees. Using this stored procedure, I am going to count the total number of female employees that are present in our table emp underscore details. So I've used my out parameter and I'm creating a new variable called total underscore EMPs. The data type is integer. Here in the select statement, I'm counting the names of the employees, and the result I am storing it in total underscore EMPs. I have used my where condition where the gender or the sex is female. So let's run this. Okay, so we have created our stored procedure. Let's refresh this. Okay, you can see we have our new stored procedure sp underscore count employees. Now to call it, I'll write call the name of the procedure, that is count underscore sp underscore count employees. Within brackets I'll pass in the parameter as @ f underscore emp. I'll give a semicolon. Then I'll write select @ f underscore emp as female employees. Okay, so as is an alias name, let's run this one by one. First I'll call my procedure and then we'll display the total number of female employees. You can see in our table we have 3 female employees. Alright, now with this understanding, let's move on to our next topic in this tutorial on advanced SQL. Now we are going to learn about triggers in SQL. So I'll give a comment here, triggers in SQL. So first let's understand what is a trigger. So a trigger is a special type of stored procedure that runs automatically when an event occurs in the database server. Now there are mainly 3 types of triggers in SQL. We have the data manipulation trigger, we have the data definition trigger, and login triggers. In this example, we will learn how to use a before insert trigger. So we will create a simple students table that will have the student's roll number, the age, the name, and the student's marks. So before inserting the records to our table, we'll check if the marks are less than 0. So in case the marks are less than 0, our trigger will automatically set the marks to a random value, let's say 50. So let's go ahead and create our table, that is students. Alright. So I'll write create table student . Now this table will have the student roll number, the data type is integer, it will have the age of the students, again the data type is integer, we have the names of the students, so the third column would be name, the data type would be variable or varying character, size I am giving it as 30, finally we have the marks as floating type. So let's create this table which is student. So we have created our table. Now I'll write my trigger command. So trigger command will start with delimiter like how our usual stored procedures have. Next, this time I'll write create trigger. Then you need to give the name of the trigger, that is mark underscore, let's say verify. I'm going to use a before insert trigger, so I'll write before insert on my table name, that is student. Next I'll write for each row if new dot marks is less than 0, then we'll set new dot marks equal to 50. So this is my condition. First we'll check before inserting. If any student has marks less than 0, we'll assign a value 50 to that student, because usually the marks are not less than 0 in any exam. I'll write end if semicolon and I'll close the delimiter. So this is my trigger command. I'll run it. It says trigger already exists. So in this case we need to update the trigger name. Let's say I'll write marks underscore verify underscore student for ST. Let's run it again. Okay, there is an error here because in our table the column name is mark and not marks. So here we need to change it as mark instead of marks. Alright, let's run it. Okay, so we have created our trigger. Now let me insert a few records to the student table. So I'll write insert into student. I'll write values. I'll give the values as 501, which is the student roll number. The age is, let's say, 10. The name is, let's say, Ruth. And the marks is, let's say, 75.0. Give a comma. We'll insert our second student record. Student roll number is 502. Age is 12. The name is, let's say, Mike. And this time I'm purposely giving a value of minus 20.5. Give another comma. We'll insert the third record for student roll number 503. Age is 13. The name is Dave. And let's say the marks obtained by Dave is 90. Now we'll insert our final record for student number 504. The age is 10. Name I'll enter as Jacobs. And this time again I'm purposely giving the marks in negative 12 point, let's say 5. I close the bracket and give a semicolon, and I'll run my insert statement. Okay, so we have inserted 4 rows of information to our student table. Now let me run the select query. I'll write select star from student. If I run this, you see the difference. There you go. So originally we had inserted for 502 the marks was minus 20.5, and for 504 for Jacobs the marks was minus 12.5. Our trigger automatically converted the negative marks to 50, because when we created our trigger we had set our marks to 50 in case the marks were less than 0. So this is how a trigger works. Now you can also drop a trigger or delete a trigger, you can just write drop trigger followed by the trigger name. In this case, our trigger name is marks_verify_st. I'll just paste this here, and if you run this, it will automatically delete your trigger. I'll give this as a comment. Okay. Now moving on. Now we are going to learn about another crucial concept in SQL which is very widely used. This is known as views. So views are actually virtual tables that do not store any data of their own but display data stored in other tables. Views are created by joining one or more tables. I'll give a comment as views in SQL. Okay. Now to learn views, I am going to use my table which is present inside Classic Models database. Now this database, as I mentioned, we had downloaded it from the internet. So first of all, let me write use Classic Models. So I'll switch my database first. Alright, now we are inside Classic Models. So here, let me show you one of the tables which is called customers. So I'll write select star from customers. Okay, I missed S here. Let's run it again. So this is my customer table which is present inside Classic Models database. It has the contact last name, the contact first name, the customer name, customer number, we have the address, state, country and other information. Now I'll write a basic view command using this customer table. The way to write is, I'll write create view followed by the view name which is cust_details. Then you write as select. I'm going to select a few column names from my original customer table, which is this one. So I need the customer name. Let's say I need the phone number and the city. So you have this information here. You have the phone number and the city. Alright. I'll write from my table that is customers. If I run this, my view that is cust details will be created. Let's run it. There's some error here because the name of the table is customers and not customer. I'll give an S and I'll run it again. Alright, so you can see we have created our view, and to display the contents that are present inside our view, I can write select star from followed by the view name that is cust_details. Let's run it. There you go. So we have the customer name, the phone number and the city of the different customers that we have in our table. Alright. Now let's learn how you can create views using joins. So we'll join two different tables and create a view. So for that, I am going to use my products table and the products lines table. I'm talking about the products table and the product lines table present inside Classic Models database. So before I start, let me display the records that are present inside the products table. Let's run it. So these are the different products you can see here. Now let's see what we have in product lines table. So we have the product line, the text description, and there is some HTML description and image. So I'll create a view by joining these two tables and will fetch specific records that are present in both the tables. So let me first start by writing create view followed by the view name that is product_description, as I'll write select product name, comma, then I'll write quantity in stock. I also want the MSRP. Now these three columns are present inside the products table, and next from the product lines table, I want the text description of the products. So I'll write from products table. I'll give an alias as P followed by inner join my other table, that is product lines, as let's say PL on the common column, that is product line. So P dot product line is equal to, I'll give a space, PL dot product line. Okay. So here we have used an inner join to fetch specific columns from both the tables, and our view name is product underscore description. Let us run it. Alright, so we have our view ready. Now let me view or display what is present inside our product underscore description view. I'll write select star from product underscore description. Let's run it. There you go. So we have the product name, the quantity in stock, MSRP, and textual descriptions of the different products in the table. Okay. Now there are a few other operations that you can perform. Let's say you want to rename a view. Instead of product underscore description, you want to give some other name. So I'll just give a comment, rename description. So to rename a description, you can use the rename statement. I'll write rename table product underscore description, which is my old name. I want to change this name to, let's say, I'll give vehicle description, since all our products are related to some of the other vehicle. So I'll write vehicle description. Okay, let us run it. Alright, so here you can see I have renamed my view. So here if I just refresh it and I'll expand this, you can see we have the cost details view and we have the vehicle underscore description view. Okay, now either you can view all the views from this panel or you can use a command. Let's say I'll write display views is the comment. Now to show all the views, you can use show full tables, where table underscore type is equal to, within single quote I'll write view. So this is the command that will display all the views that are present inside a database. There is some error here. Let's debug the error. This should be okay. So instead of table types, it should be table type equal to view. Let's run it. You can see the two different views that we have. One is customer details, another is vehicle underscore description. Okay, now you can also go ahead and delete a view. For that you can use the drop command. So I'll write drop view followed by the view name. Let's say I want to delete customer underscore details or cust underscore details view. I'll write drop view cust underscore details. Let's run it. You can see here we don't have the cust underscore details view anymore. Alright, now moving to our final section in this demo. Here we will learn about Windows functions. Now, Windows functions were incorporated in MySQL in the 8.0 version. So Windows function in MySQL are useful applications in solving analytical problems. So using the employees table present inside my SQL underscore intro database, so we'll find the total combined salary of the employees for each department. So first let me switch my database to SQL underscore intro database. I'll run it. Okay, I'll display my table, that is employee. So here we have 20 employees in our table. Using this table, we are going to find the combined salary of the employees for each department. So we'll partition our table by department and print the total salary. And this we are going to do using some Windows functions in MySQL. So I'll write select. I want the employee name, the age of the employee, and the department of the employee, comma. Next I'll write the sum of salary over. I want to partition it by department. So I'll write partition by department, which is DPT, and I'll give an alias as total salary so that it will create a new column with the name total salary from my table, that is employees. The output will be a little different this time. Let's execute it and see the result. There you go. So here we have created another column in our result, that is total salary, and for each of the employees and the respective departments we have the highest salary. So in finance, the highest salary of one of the employees was $155,000. Similarly, if I come down, we have the highest salary from HR. If I scroll further, we have the highest salary from IT, marketing, product, sales, and the tech team. Alright, now we'll explore a function which is called row number. Now the row number function gives a sequential integer to every row within its partition. So let me show you how to use the row number function. I'll write select row underscore number function over my column would be salary. So I'll write order by salary. I'll give the alias as row num, give a comma, and I want to display the employee name and the salary of the employee from my table, that is employees, and I'll order by salary. So let's see how our row number function will create sequential integers. Okay, you can see here we have a row num column and we have successfully given row numbers to each of the records. You can see it starts from 1 and goes up till 20. Okay. Now this row number function can be used to find duplicate values in a table. To show that, first I'll create a table. I'll write create table. Let's say I'll give a random name, that is demo. And let's say we have in this table the student ID, which is of type integer, and we have the student name, which is of type varchar. The size is 20. I'll create the small table with a few records. Let's create this table first. Now we are going to insert a few records to our demo table. So I'll write insert into demo values. I'll give 101. The name is Shane. Give a comma. I'll insert the second student name 102. The name is Bradley. I'll give a comma. This time for 103 we have 2 records. Let's say the name of the student is Herath. I'll give a comma. I'll copy this and we'll paste it again. So we have duplicated 103. Next we have 104. The name of the student, let's say, is Nathan. Then again, let's say for the 5th student, which is Kevin, we have 2 records. I'll copy this and I'll paste it here. Let me give a semicolon and we'll insert these records to our table demo. Alright. Now let me just run this table for you. I'll write select star from demo. If you see this, we have a few information that are duplicated in our table, that is for student ID 103 and student ID 105. Now I am going to use my row number function to find the duplicate records present in my table. I'll write select student underscore ID comma student underscore name. I'll give another comma and write row underscore number over, within brackets I'll write partition by st underscore id comma st underscore name. Okay, then I'll write order by st underscore id, close the bracket. I'll give an alias as row num from my table, that is demo. Let's just run it. You can see here, okay, let me just delete n from here and do it again. Alright, now if you see here, there is just one student in the name Shane. We have one student in the name Bradley. But here if you see, for Herath, the second record it says 2, which means there are 2 records for Herath. And if I scroll down, there is 1 record for Nathan and there are 2 records for Kevin, which means Kevin is also repeated. Okay, now we are going to see another Windows function that is called rank function in MySQL. So the rank function assigns a rank to a particular column. Now there are gaps in the sequence of ranked values when 2 or more rows have the same rank. So first of all, let me create a table, and the name of the table would be a random name. We'll give it as, let's say, demo1, and it will have only one column, let's say variable a of type integer. We'll create this table first. Okay, now let's go ahead and insert a few records to our table, which is demo1. So I'll write value 101, 102, let's say 103 is repeated. I'm doing this purposely so that in the output you can clearly distinguish what the rank function does. Next we have 104, 105, we have 106, and let's say 106 is also repeated. Finally we have 107. Okay, let me insert these values to my table, that is demo1. Okay, this is done. Now if I write select var underscore a and use my rank function, I'll write rank over, then I'll order by my variable, that is var underscore a, as an alias name, let's say test rank, from my table, that is demo1. Let me execute this and show you how the rank function works. Now if I run this, there you go. So here if you mark, so for variable a101 the test rank is 1, for 102 the test rank is 2, but for this value which is 103 the test rank is repeated because there was a repetition for 103. So we have skipped the rank 4 here. For 104 the rank is 5 now, for 105 the rank is 6 now. For 106 again, since the record was repeated twice, we have skipped the 8th rank and our rank function assigned the same value, which is 7 for 106, and for the last value 107 the rank is 9. Alright. Now moving ahead, we'll see our final Windows function, which is called first value. So first value is another important function in MySQL. So this function returns the value of the specified expression with respect to the first row in the window frame. Alright. So what I'm going to do is, I'm going to select the employee name, the age and salary, and I'll write first underscore value, which is my function, and pass in my employee name, and then I'll write over order by my column, that is salary descending. I'll give an alias as highest underscore salary from my table, that is employees. So let me run this and see how the first underscore value function works. Alright, so in our table, Joseph was the employee who had the highest salary, which was $115,000. So the first value function populated the same employee name throughout the table. You can see it here. Now you can also use the first underscore value function over the partition. So let's say you want to display the employee name who has the highest salary in each department. So for that you can use the partition. I'll write select emp underscore name, comma, I want the department and the salary, comma, I'll use my function, that is first underscore value, followed by the name of the employee inside my first value parameter. I'll write over, here I'm going to use partition. I'm going to partition it by department, since I want to know the employee name who has the highest salary in each department. And I'm going to order by salary descending, and I'll give my alias again as highest salary from my table, that is employees. So let's run this and see the difference in the output. Okay, so as you can see here, we have the employee who had the highest salary from each department. So for finance, Jack had the highest salary. From HR it was Marcus. Similarly in IT it was William. If I scroll down, for marketing it was John. For product it was Alice who had the highest salary. Similarly in sales we had Joseph, and in tech we had Angela. So this is how you can use the first underscore value function using partition. Alright, so that brings us to the end of this demo session on our tutorial. So let me just scroll through and show you what we did from the beginning. First we learnt about subqueries in SQL. So we initially wrote a simple subquery, and then we used our classic models database, which was downloaded from the internet. I'd also shown you the link from where you can download this database. Here we used two different tables and we performed a subquery operation. We learned how to create stored procedures. So we learned how you can use the in operator or the in parameter as well as the out parameter in stored procedure. After stored procedure, we learned another crucial concept in SQL, which is called triggers. Now triggers are also a special kind of stored procedures. So we saw how to write a before insert trigger. You can see it here. Next, we learned how to delete a trigger. We also saw how to work with views in SQL. So views are basically virtual tables that you can create from existing tables. We also saw how you can use views using two different tables and an inner join. And we learned how to display views, how to rename view names, how to delete a view, and finally we explored a few Windows functions.
Let's embark on this transformative adventure together. Having said that, if you're an aspiring business analyst looking for online training and certifications from prestigious universities and in collaboration with leading experts, then search no more. Simplilearn's postgraduate program in business analysis from Purdue University in collaboration with Amazon, Google, and Microsoft should be a right option. For more details, use the link in the description box below.
Hello and welcome to the Business Analytics with Excel course offered by Simplilearn. This video will give you an overview about the importance of analytics in business today, why it is in demand among a lot of organizations, and how you can effectively leverage Microsoft Excel for data analytics. It is quite clear that businesses must understand the changing market and trends in social media to stay ahead of the competition and drive effective business decisions. What can help businesses maintain their competitive edge? The answer lies in business analytics. The term business analytics refers to the skills, technologies, applications, and practices that facilitate continuous iterative exploration and investigation of past business performance, customer data, and competitive landscape data. The goal is to gain insights and drive business planning. Therefore, business analytics empowers businesses to automate and optimize business processes, thereby enabling them to sustain the competitive advantage. Microsoft Excel has extensive analytics capabilities to perform statistical analysis. With the added advantage of visibility, a flat learning curve, and good reporting functionalities, Excel has become the tool of choice to start your data analytics journey. Did you know Excel offers intuitive analytics features such as Find, Connect, and Shape to model and analyze a company's data? Today, Excel comes with in-memory technology that makes it easily compatible with millions of bytes of data, enabling companies to perform the necessary analysis without being dependent on specialized solutions. Additionally, features such as Power Business Intelligence, including Power Pivot, Power Query, Power View, Power Maps, and so on, easily integrate with Excel. The sandbox-like Excel environment makes data exploration and deriving results quite easy. It includes features to perform powerful data analytics processes with just one click instead of using a complex set of formulas, pivot tables, and manual steps. With increasingly diverse toolsets being added to Excel, it's very clear that Excel is the business intelligence tool of choice and the future of business intelligence workflows, and is being increasingly preferred by analysts, reporting professionals, and BI people. Excel provides a grid-like interface of rows and columns, enabling users to organize and format data better. The data can be simple text, numbers, dates, or other supported formats. Excel's libraries span a large range of functions, from basic math to complex statistical formulae. It cannot be said enough that Excel is pivotal to organizations, as it is the leading user-friendly analytical tool. Amazon, an American electronic commerce and cloud computing company, has been in business for more than 20 years. It has a user base of millions of customers. Ever wondered how Amazon predicts exactly what customers want to buy? It's simple, or let's just say it's simple business analytics that involves understanding the patterns of what happened in the past to predict what might happen in the future. Currently, this is a requirement of every business. Simplilearn's Business Analytics with Excel course introduces you to Excel, the powerful data analysis tool that will enable you to collect data and perform an in-depth analysis of the data to drive effective, impactful business decisions. Designed to build upon the concepts and procedures in data analytics, the primary focus of the course is to learn how to use Excel to perform multivariate statistics and to understand how to explore, experiment, and forecast results with Excel's histograms, pivot tables, statistics, and mathematical formulas and charts. After attending this course, you should be able to understand business problems and datasets, perform calculations using statistical techniques, conduct a variety of statistical analyses, including regressions, covariance, correlation, and testing hypothesis, present and interpret the results of statistical analysis, design dynamic reports and dashboards for business consumption. This highly engaging course features concept videos with exercises which will empower you with hands-on experience. The course covers Introduction to Business Analytics with an overview to different types of analytics, statistical and mathematical functions. After each lesson, practice and revision assessments are provided to reinforce the concepts learned. The course ends with detailed case studies outlining real-life scenarios. Simplilearn will offer complete support anytime during the course or while you're working on the projects. If you subscribe to the live virtual classroom training, you can attend an ongoing batch and revisit important concepts to seek help for the projects. Visit the Simplilearn website, www.simplilearn.com, and click Help and Support at the bottom of the page to submit queries. You can also speak directly to the support staff with the Simply Talk or live chat option. So, are you ready to begin? Happy learning!
Hello, and welcome to the lesson Formatting, Conditional Formatting, and Important Functions. In this lesson, we will learn about custom formatting, how to use conditional formatting and formulas, and implement logical, statistical, and mathematical functions. Let's say we need to differentiate the sales value from the given data set as above target, below target, and met target. As a data set can be huge and complex, differentiating each value manually would consume a lot of effort and time. Here comes the Excel features such as formatting and conditional formatting, which enables us to perform this task easily. Formatting, as the name suggests, helps us to format the data using different techniques, making the data easy to read in the required format and analyze them. The right formatting technique applied to the worksheets can help the users present the data efficiently. Conditional formatting, a type of formatting, helps us visually explore and analyze data, detect critical issues, and identify patterns and trends. Conditional formatting helps to add patterns and trends to the raw information using different colors, icons, and formulae, etc. At times, we also need to perform mathematical operations and calculations within our data set. Excel provides a large number of logical, statistical, and mathematical functions such as VLOOKUP, HLOOKUP, and, if, not, rank, quartile, and many more that can help the users to perform calculations ranging from basic to complex operations. These inbuilt functions help us to manage data and perform descriptive statistical analysis. Excel also offers a wide range of important formulas that help to perform many common tasks. These formulae may be as simple as basic addition, or it could be a complex combination of inbuilt Excel functions. Before going into details, let us start this lesson by defining the objectives of the lesson. The worksheets appear more polished and easy to read if proper formatting techniques are applied to it. We can format the cells in Microsoft Excel manually by selecting fonts, font color, font size, background colors, and borders. We can also use numerous predefined table styles or quick styles to quickly format a table automatically. This is the basic formatting in Excel. If these built-in functions do not meet our needs or do not display the data in the format that we require, we can create our own custom format. In this topic, we will focus on custom formatting in Excel. Let's say we want to display 1,532,000 as 1.53 M, or the 1st of January 2016 date, with a weekday as the first Friday, January 2016. Here we can use custom formatting feature of Excel. Let's see how we can accomplish this in Excel. In this lesson, we shall consider the following fields from our master table: dates, order ID, product, salesman, region, number of customers, net sales, and profit and loss. Here in the given worksheet, we have a column named net sales. Suppose we want to display the values of net sales in terms of thousands. For example, 7,164 should be displayed as 7.16K. Select the entire column for net sales. Under the Home tab, click the drop-down present in the Numbers panel. Select the option More Number Formats. A Format Cells dialog box appears. From the category list, select the type as Custom. In the Type text box, enter number, column, number 0, decimal 00, comma, open double quote, capital K, close double quote. Here, number is the digit holder with 1,000 comma separation. Each comma after .00 indicate divide value by 1,000. The 2 zeros after decimal point indicate number of value after decimal places. The K component displays a literal K character to denote thousands. Here we can see the preview in sample box. The value shown is 7.16K. Finally, click OK button. The values in column net sales are now displayed in terms of thousands. Now let us consider another example of date formatting. In the column dates, we have a date value written as 1st Jan 2012. We want to display it as 1st Sunday, Jan 2012. First, select the column containing dates. Under the Home tab, click the drop-down present in Numbers panel. Select the option More Number Formats. A Format Cell dialog box appears. From the category list, select the type as Custom. In the Type text box, enter DD-DDD-MMM-YY. Here, D stands for date, M stands for month, and Y stands for year. The first 2DD is the date. The next 4, DDDD, is for weekday, say Thursday. Then MMM is for the month in short form, and YY is for year. Here we can see in the preview in the sample box, the value shown is 1 Sunday, Jan 12. Finally, click on OK button. Thus, the custom formatting helps us in changing the appearance of the cell value according to our needs. A worksheet may contain thousands of rows of data. By simply examining the raw information, it would be difficult to see patterns and trends. Conditional formatting helps us visualize data that make worksheets easier to understand. It quickly highlights important information in a spreadsheet by using colors, icons, and data bars. It changes the appearance of one or more cells when the cell value meets certain criteria. To do this, we need to create a conditional formatting rule. For example, a conditional formatting rule can be, if value is greater than 5,000, color the cell yellow. By applying this rule, we will be able to quickly see which cells contain values that are greater than 5,000. Let us understand this with the help of examples. Consider the given sales table, which depicts the amount of sales done by each salesman. Here, we want to highlight the duplicate order ID values. First, select the order ID column. Click Home tab. Under Styles panel, select the option Conditional Formatting. From the drop-down menu, hover the mouse over Highlight Cells Rules and select Duplicate Values. A Duplicate Values dialog box appears. Select a formatting style from the drop-down menu. In our example, we will choose Green Fill with dark green text. Click OK. Here, we can see that the conditional formatting is applied to the column Order ID. Excel highlights all the duplicate cells with green fill with dark green text. We can also explore other options available in conditional formatting, like greater than, less than, between, equal to, text that contains, a date occurring, and top/bottom rules. All these rules work in the similar format. Excel provides predefined styles to quickly apply conditional formatting to our data. They are data bars. Data bars are horizontal bars added to each column, much like a bar graph. Color scales. Color scales change the color of each cell based on its value. Each color scale uses a 2 or 3 color gradient. Icon sets. Icon sets add specific icon to each cell based on its value. Let us consider another example to explain how icon set rules are used. Consider the given sales table. Here, on the basis of the sales amount, we want to apply the icon set rule. If sales amount is greater than 8,000, then a green arrow should appear in the upward direction. If sales amount is between 5,000 and 8,000, then show a yellow arrow in the horizontal direction. And if sales amount is less than 5,000, then show a red arrow in the downward direction. To perform conditional formatting, select the desired cells, click on Home tab. Under Styles panel, select the option Conditional Formatting. From the drop-down menu, hover the mouse over Icon Set Rules and select the first rule. Again, click on Conditional Formatting, select the option Manage Rules from the drop-down. A Conditional Formatting Rules Manager dialog box appears. Go to Icon Set Rule and select 3 Icon Set Rule. Click on Edit Rule, and an Edit Rule Formatting dialog box appears. By default, for 3 Icon Set Rule, Excel uses the 67th percentile and the 33rd percentile rule. This means that it shows a green arrow for values greater than 67%, yellow arrows for values between 67 and 33%, and red arrow for values less than 33%. Now let us customize this rule for our criteria. In the Type drop-down, select the option As Number. In the Value Reference box, enter value as 8,000 for green color arrow and 5,000 for yellow color arrow. Excel automatically picks the criteria for the red color arrow. Click OK. In the Conditional Formatting Rules Manager window, click OK. We can see that the cells are highlighted as per our criteria. Cells which have a value greater than 8,000 have a green arrow in the upward direction. Values between 5K and 8K are highlighted with a yellow arrow, and values less than 5K are highlighted with a red arrow. We can also apply conditional formatting rule with the help of formulas. Consider the given table, which shows the profit done by each salesman. Here, we want to highlight the rows in the table wherever profit is greater than 4,000. Select the entire table along with headings. Click on Conditional Formatting. Select the option New Rule from the drop-down. A new formatting rule dialog box appears. Under Select Rule Type, select the option Use a formula to determine which cells to format. Under Format Values Reference box, enter the formula as equals if, open bracket, $H2 greater than 4,000, comma, true, comma, false, close bracket. This will apply formatting to a cell if the profit is greater than 4,000. Click on Format button. From the Format Cells dialog box, select the Fill tab. From the Color dialog box, select the color as green. Finally, click OK. The conditional formatting is successfully applied to the cells. Here, we can see that the cells with the profit greater than 4,000 are highlighted with the green color. Logical functions evaluate a cell or cells for a criteria and returns a Boolean value, true or false. In this topic, we will cover various logical functions like if, and, or, not, true, false. Consider the given sales table. Here, on the basis of the sales amount, we want to determine the commission percentage of each salesman. Following is the criteria. If net sales greater than or equal to 10,000, set commission as 5%. If net sales greater than or equal to 5,000 and less than or equal to 10,000, set commission as 2.5%. If net sales less than 5,000, set commission as 1.5%. This is a common condition where we're required to create a between formula that picks all values between the two given values. In such conditions, we use if with the AND function. Let's write the formula in cell I5. Like any other formula, we will start with the equal sign. Then type our function name, if, and then type an open parentheses. The first parameter we need to pass is a logical test. Here, the logical test is if sales, cell G5, greater than or equal to 10,000, assign value as 5%. Then we will pass the second logical test. Here, we will use AND function. If, open bracket, and, open bracket, sales at cell G5 greater than or equal to 5,000, comma, at cell G5, less than or equal to 10,000, comma, assign value as 2.5%. In the else parameter, we will type 1.5%. This means that if the first two cases become false, then the formula will assign the value 1.5. Finally, close the two braces for the two ifs. Thus, Excel returns the result as 2.5% for cell G5. Now drag the formula with the help of the fill handle. We can see the results for the other cells as well. The OR function returns true if any of the conditions are true and returns false if all of the conditions are false. In the given table, we are required to assign performance remarks for each salesman as per the scaling table. In scaling table, we have the criteria that if net sales greater than 10,000 or profit greater than 5,000, set remark as good. Else, set remark as needs improvement. Let's write the formula using if and or to check sales and maximum sales in cell J5. So our formula becomes equals if, open bracket, or, open bracket, G5 greater than 10,000, comma, H5 greater than or equal to 5,000, comma, double quote, good, double quote, comma, double quote, need improvement, double quote, close bracket. Let's drag this formula across the cells with the help of the fill handle. This formula will return true if any of the condition is true. Thus, in the given example, the cell J9 returns good, even if profit is less than 5,000. Our next function is true/false. True/false returns true and false respectively if we write them in any cell. The not function reverses the result of the function. If result is true, it returns false, else true. Let's write formula as equal, not, open bracket, K5, close bracket, in cell L5. This returns the result as false. Let us now study about different lookup and reference functions used in Excel, such as VLOOKUP, HLOOKUP, match, index, and offset function. The VLOOKUP function lets us search for specific information in the current worksheet. Say we have a list of students with marks. We can search for the marks of a specific student. If our table is in horizontal format and we want to determine a specific value, then we use the HLOOKUP function. Consider the extract from our master sales table. The table depicts sales information based on order ID, products sold, salesmen, and net sales. Now we want to determine the net sales corresponding to order ID 1121. Let's understand how we can accomplish this using the VLOOKUP function. Note that VLOOKUP function is only used for vertical tables. Let's use cell I2 to add the formula. Like any other formula, we will start with the equal sign, then type our function name, VLOOKUP, and then type an open parentheses. Now we will add the arguments. The first argument is lookup value. Lookup value corresponds to the value or item we are searching for. So, in our example, it will be order ID 1121, cell H2. The second argument is table array. Table array is the cell range that contains the data. In this example, our data is in cell B2 to E40. The third argument is call index num, column index number. The column index number is the column number in which we are looking for information. Here, in our table array, net sales is the fourth column, so our third argument will be 4. The fourth argument is range lookup. This value corresponds if we are looking for approximate matches or not, and can have value either true or false. True denotes the approximate match, and false denotes the exact match. Here, we will pass false. Finally, close the parentheses. So our function has the form equal VLOOKUP, open bracket, H2, comma, B2, colon, E40, comma, 4, comma, false, close bracket. We can see that the function returns the value as 2277. Note that the VLOOKUP function works from left to right. That means the lookup value should always be present in the leftmost column of our table array. If our table is in horizontal format and we want to determine a specific value, then we use the HLOOKUP function. Consider the given table. Let's write the formula in cell I4. We will start with the equal sign, then type our function name, HLOOKUP, and then type open parentheses. The first argument is the lookup value. So in our example, it will be order ID equals 1121. Cell 84. The second argument is table array. In this example, our data is in cell G8 to AS11. The third argument is row index number. Here, our table array net sales is the fourth row, so our third argument will be 4. The fourth argument is range lookup. Here, we will pass false. Finally, close the parentheses. So our function has the form equals HLOOKUP, open bracket, H4, comma, G8, colon, AS11, comma, 4, comma, false, close bracket. The function returns the value 2277. Note that HLOOKUP function works from left to right. That means lookup value should always be in the topmost row of your table array. The match function searches for a specified value in an item in a single dimensional array, and then returns the relative position of that item in the array. Let us understand its functioning with the help of an example. Consider the given sales table shown. Here, we want to determine the position of the corresponding date in the original table. So let's write the formula in cell E5. Type equal sign, then type the function name, match, and then type an open parentheses. The first argument is the lookup value. So in our example, it will be date in cell B5. The second argument is lookup array. The lookup array is a range of cells that contains the value we are searching for. In this example, we will select the cells B17 to B1342. The third argument is match type. Match type can be either -1, 0, or 1. The value should be 1 if we want to find the largest value less than or equal to the lookup value. The value should be 0 if we want to find the first value exactly equal to lookup value. It should be -1 if we want to find the smallest value greater than or equal to lookup value. Here, we will pass the match type as 0, as we require an exact match. Finally, close the parentheses. So our function should look like match, open bracket, B5, comma, $, B, $17, colon, $B, $1342, comma, 0, close bracket. This returns the value as 3. Now we can drag the formula across cells with the help of the fill handle. Similarly, we can use the match formula in cell E3 to determine the position of the shown field name, cell C3, in range B17 to I17. For example, net sales is at 7th position in the range B17 to I17. Let's write the function in cell E3. Write formula as equal sign, match, and open parentheses. In the first argument, select cell C3. For second argument, select cells B17 to I17. Pass third argument as 0, Finally, close the parentheses. So our function looks like equal match, open bracket, C3, comma, $B, $17, colon, $I, $17, comma 0, close bracket. So for profit loss field, the value returned is 8. Net sale, the value returned is 7. The index function returns value from a specified position in a specific column in a list. Suppose we want to determine the value of a field mentioned in cell C3 from the sales table on a specified date. The table should dynamically fetch the value if the value of the cell C3 is changed. If we enter profit loss, formula should fetch the profit loss value for the specified date. If we write net sales in cell C3, then formula should fetch net sales value for specified date. So let's use the index function to determine the value in this worksheet. Select cell C5, write formula as $, index, and open parentheses. The first argument is the array. For our example, enter B17, colon, I1342. The second argument is the row num. This corresponds to the row number that has the value we want to return. Here we will enter E5, which denotes the required date. The third column is col num. This corresponds to the column number that has the value we want to return. Here we will enter E3, which denotes the position of the field name in cell C3 in table. Finally, close the parentheses. Thus, our formula returns the value as 6,528 based on the position at cells E5. This is the net sales value on the date the 2nd of January. Now drag the formula with the fill handle to the other cells as well. The offset function returns a reference to a range that is the offset number of the rows and columns from another range or cell. Now let's understand how to use it. Select cell D5, write formula as $, offset, and open parentheses. The first argument is the reference. This denotes the starting range from which the offset will be applied. For our example, we will select the reference cell as B17. The second argument is the rows. This denotes the number of rows to apply as the offset to the reference. This can be a positive or a negative number. So for our example, we will enter E5 minus 1. Here, we are subtracting 1 to match number of row which have the value and the offset from the reference cell. The third argument is the cols. This corresponds to the column number that has the value we want to return. Here, we will enter E3, which denotes the position of the field name, and subtract by 1 to match with the offset referencing. Finally, close the parentheses. The function returns the value based on the position of date from cell B5 and field from cell C3. Now drag the formula across the cells with the help of the fill handle. If we enter profit loss, formula should fetch the profit loss value for the specified date. A variety of statistical functions are available in Excel to perform calculations ranging from basic function, mean, median, and mode, to more composite distribution and test, binomial or chi-square. In this topic, we will cover various statistical functions like SUMIF, COUNTIFs, percentile, quartile, standard deviation, and median. SUMIFs and COUNTIFs are the most frequently used functions in Excel. These functions allow us to perform count and sum based on one or more criteria. The SUMIFs function calculates the sum of cells based on certain criteria. Let's understand how to use the function with the help of an example. Consider the given sales table. Say we want to determine the net sales done by salesman Justin. Here, we will use the SUMIFS function to calculate net sales. So let's write the formula in cell N4. Type equal sign, then type the function name SUMIFS, and then type an open parentheses. The first argument is the sum range. This is the input range that contains the required data. So in our example, we will select cells H4 to H1328. The second argument is the criteria range. This denotes the range that contains the required criteria. Here, we will pass the range that holds salesman's name, cells E4 to E1328. The third argument is criteria. This corresponds to our required criteria. We only require net sales of the salesman Justin, so we will select cell M4. Finally, close the parentheses. Note that we can pass multiple criteria in this function. The function returns the net sales done by Justin. COUNTIFs function works in a similar manner like SUMIFS. It counts the number of cells in a given range when certain criteria is met. Say in the given sales table, we want to determine the total number of sales for net sales greater than 8,000. To determine the count, we will use the COUNTIFs function. So let's write the formula in cell N5. Type the equal sign, then type the function name, COUNTIFs, and then type an open parentheses. The first argument is the criteria range, 1. This denotes the range that contains the required criteria. Here, we will pass the cells containing net sales, H4 to H1328. The second argument is criteria 1. This corresponds to our required criteria. We only require entries with net sales greater than 8,000, so we will enter greater than 8,000. Finally, close the parentheses. Note that the function allows you to enter multiple criteria. Cell N5 reflects the total number of sales as 445 for net sales greater than 8,000. In this topic, we will learn how to use the functions percentile, quartile, standard deviation, and median in Excel. Consider the given sales table. Let's see how to use the percentile function on net sales to find its 40th percentile. Select the cell N6. Write the formula as equal sign, percentile, open bracket. Select the column net sales H4 to H1328 as our first argument. Pass the second argument as 0.4 in order to find the 40th percentile. This returns the result 5,220. This means that 40% of the net sales is less than or equal to 5,220. The next function is quartile. Quartile function depicts the results for the first, second, third, and fourth quartile. Say we want to find the total number of sales which are less than or equal to 25%. Let's use the quartile function to calculate this. Select cell N7 to write the formula. Type equal sign, function name is quartile, and open braces. Select net sales column H4 to H1328 as the first argument. Type 1 as the second argument. The second argument must be a number between 0 and 4. The function returns the value as 3,822, which means that 25% of the sale is less than or equal to 3,822. Note that here we can use the percentile function to perform the same task. The function percentile H4 to H1328, 0.25 gives us the same result. It's up to us which function we would like to use for the quartiles. Excel has a function to calculate sample standard deviations, STDEV. Standard deviation determines how dispersed the data is from the mean. Say we want to calculate the standard deviation for a number of customers. So write the formula in cell N8 as equals the function name STDEV, open braces. Select number of customers columns as its argument. the function returns the result 1.4. The median function returns the value from the range. For example, we want to find the mid value for net sales. To calculate median in cell N9, write the formula as equal sign, the function name median, then open braces. Select net sales column as its argument. This calculates the mid value of net sales as 6,192. Rank function is used to compare a number from the rest of the numbers in a list in any order, whether ascending or descending. This function returns the rank of the number relative to the other values in the list. Let's use rank function in cell J4 to calculate rank on the basis of net sales. Select cell J4 and write the formula as equal sign, then type the function name rank, and then type an open parentheses. The first argument is the number. This is the value whose rank we are required to calculate. Here we will pass the argument cell H4. The second argument is ref. This corresponds to the array or reference list. Here we will select the column net sales, i.e. cells H4 to H1328. The third number is order. This specifies how to rank the number. 0 means descending order and 1 denotes ascending order. This argument is optional. If we don't pass any argument, Excel automatically takes the argument 0. Here we will pass 0. Finally, close the parentheses. Here we can see that Excel has determined the rank for net sales 7,164 as 553. Finally, we can drag the formula and can see the rank for the other cells based on net sales.
Let's embark on this transformative adventure together. Having said that, if you're an aspiring business analyst looking for online training and certifications from prestigious universities and in collaboration with leading experts, then search no more. Simplilearn's postgraduate program in business analysis from Purdue University in collaboration with Amazon, Google and Microsoft should be a right option. For more details, use the link in the description box below.
In this session, we will start with certain exercises which we will perform in Tableau in order to understand some basic concepts. Now, in order to learn Tableau, the basic first step is to import a sample data. So in our case, what we have done is we have imported a sample superstore, which is in Excel format, a sample superstore.excel, which has 3 worksheets in it: orders, people and returns. So by importing this data into Tableau, first of all, we will create relationships between these sheets in order to identify who all have placed orders and how many people have returned the orders. We will do some analysis on the orders placed by a certain set of people and order returned by a certain set of people. Now, as we have imported the sheet, we will make certain joins. So the first step is to drag the orders table, the order sheet on the relationship canvas here, okay, and you can see the data, sample data, the first 100 rows over here, okay. Then now we need to create an inner join with people's table between order and people, okay. So if you see, it has automatically detected the field names on which the inner join has to be created. So on the order side, you have region, and on the right hand side, which is the people data, you have also a region, okay. So both these columns are common, and that's how we have made a join between orders and people data. So if I close this box and go and check the people's data, open. So see, the region and the person, these two columns from the people table have now been joined with the orders table, right? So it means that these are the orders in a particular region which has been placed in this region. Let me show you the sample superstore Excel file. Now, this is the structure of the file. You have a sample list of transactions, basically the orders which are placed by customers across multiple regions, south, west of USA, south region, west region. Then you have a list of order IDs which have been returned. So basically, the order ID in the returns sheet matches with those orders in the orders table. And then you have the people sheet in which you have region and a person associated with that region, the salesperson associated with that region. Okay, so basically when we are joining orders with people, we are joining that which orders belongs to which region and who's the salesperson associated with it. So what we have done over here is we have made an inner join, means all the orders should belong to particular region and that region is in the people's sheet. And then in the second step, now we will make a left join between returns and orders, not inner join. We'll make a left join between returns and orders, and we will make a join using the order ID. Okay, so just edit this, click on left and select order ID as the join column. Now, what does left join means? Left join means is that consider all the orders from the orders table and only consider the orders from the returns table which have data, means which are returned. Otherwise, show null for the order IDs which are not returned. So if you see, these are the two columns from the returns table, and these are null because this is relevant to the order IDs which are not returned, okay, which has been accepted by the customer. But these are the orders for which you see data in the returned and order ID column. It means that these have been returned. Now, with these joins in place, please save your book. And now we have our relations created in the Tableau. Now we are ready to create certain reports and extract certain KPIs using this relationship model. Now we'll move to sheet 1. Okay, and first we will place state and person on the rows sheet. Okay, then I'll go to my numbers and put the profit or so per state, per person, how much profit I am making as a company. Okay, this is my goal to check. Now sort by highest to lowest. So California is giving me the maximum profit of 76,381, then New York, then Washington. So this is the sorted order in which I have listed my profit in descending order. Now I can also check what are the number of orders placed and check the distinct count. So out of 120, out of the total orders of 127, okay, so this is the total number of orders which have been returned for California is 127. It's 16, 29. So the sorted order is as per the revenue, as per the profit, and this is the details of the orders which have been returned per state. So if you see for Connecticut, for Kansas, there are 0 returns. So you can also extract data. Table to refresh is orders and identify new rows using order date. So as and when new data is being added, you can refresh it. Now say extract, and now you can save this information, profit by state, and click save. So this is the extraction of this particular report which is possible in Tableau. So this is the first exercise which we have completed for reviewing and analyzing the profit per state, highest to lowest, and within that per state, what are the number of orders which have been returned by all the customers, the distinct count of order IDs which have been returned. Now let's start our second exercise on creating calculated fields in Tableau. Now in this exercise, we will be doing certain activities, like we will be creating a set to show the states which have more than 100 customers. Then we will be creating a calculated field to show an average sales per customer. Okay. Then we will create a calculated field to show the sales goals, and then show emerging and developing stage. So these are the 4 KPIs which we have to derive. Now, the first thing, we have our sample superstore data already imported and the relationships created, inner join with people and left join with returns. Now we have our sheet 2 in which we will create the states, a list of states which has more than 100 customers. So what we have to do is we have to right click on the customer name and click create set. Okay. Now we have to give the name as states with 100 plus customers, and then go to the condition tab, select by field, and then apply condition as count of customer name greater than equal to 100 and click OK. Now we have this set created, states with 100 plus customers. Now to determine average sales by customer, we have to now create a calculated field. So go to the analysis and click on create calculate field. Okay. Now name it as average sales per customer, and now we will say average we will use a Okay, so we are saying that per customer, we are using a level of definition function include, which means that per customer, what is my average sales, right? We've already used a function, aggregated function called average. So we are saying per customer, give me the total and then give me the average per customer. So we're going to click OK. Now create another calculated field. You can also create from here and name it as sales goal. Now in this we are going to type the formula if minimum states with 100 plus customers equal to true, then sum of sales into 1.3, else average sales per customer into 100. So we are saying that if the customer belongs to the set of states with 100 plus customers, then the sales target should be 1.3 times the actual sales as of today, else it should be 100% of the average sales per customer. Now let's create another calculated field which we call as emerging or developing state. If distinct count of customer name is greater than equal to 100, then the state is tagged as developing state, else it is called as emerging state. Okay, so we have now 3 calculated fields: average sales per customer, emerging or developing state, and sales goals. Now we will use this in our reporting. So we will drag sales goal under the columns and then I'll drop my state. So now this is the state wise sales goal, depending whether the state has 100 plus customers or not. Then add your customer name. Make the measure as count distinct and make it as discrete. Okay, so if you see this, we have the count of customers per state and the sales goal for that particular state. And now I'll put my sum of sales, the total sales which I want per, which is there per state. Now go to show me and select this particular chart, bullet graph. Now to bring sales goals to column, right click on the sales axis and select swap reference line fields. Now from your left hand panel, drag and drop emerging or developing state on the color panel. Okay, so emerging state is the orange one and the developing state is the blue one. And save the sheet as developing and the emerging states. So if you see this, it's an emerging state because its count is less than, the customer count is less than 100. Its sales goal is 57384, but the actual sales is 19511. Okay. So now this is a developing state. Its count is greater than equal to 100 and its sales goal and its sales is exactly the same. It matches. So that's why you are seeing the bar and the blue bar is ending exactly where the vertical bar is. So what we are trying to depict is that whether the state is going beyond its target sales goal or it's behind it. And you can see that using this particular vertical bar. Like for example, Michigan, its sales goal is 71,952, but its actual sales is 76,270 average sales. So that's why it is above its target and it's a developing state because it has more than 100 customers. So you can even sort by the count of the customers higher to lower. So all your developing state will group from at the top and the emerging states will group at the bottom. Or you can sort by the sales goal. So the orange bar is the sales goal or the blue bar. So depending what sales goal is being derived for each state. We are going to take example of the Netflix database which we have, and we will prepare certain reports in order to identify what kind of reports we can generate from such a data set. So currently on my screen, what you can see is the Tableau, the Netflix data sheets, the data sources, where you have the Netflix shows, movies, their associated duration, what kind of shows or movies are there, their release year, the associated rating, description, and a key, which is the show ID. Now this is the unique identifier for each show in this Netflix title sheet, and with this show ID all other sheets are related, like who are the directors of the show, in which country the show was released, what is the cast of each show, all that information is in this sheet, and to which particular category, basically the listed in category is being listed in this particular sheets. So what we are going to do is, first we are going to import this sheet into Tableau. Okay, and then create relationship between them using the Tableau relationship canvas. So first the primary transactional table, the sheet in which all the information related to movies is there or shows is there, is in Netflix titles, and then we will drag sheet like Netflix cast, titles cast. Now Tableau has automatically identified the relationship between the show ID of titles and show ID of titles cast, and it has made a join. So if you double click this, you can see this relationship, cardinality, and the related fields. Similarly, I'll drag titles category, countries, and directors. Now by virtue of this, all the sheets have now been joined with Netflix titles, and with this relationship ready, we can start preparing our reports. Now let's create a basic report where we can just glance the data, like whatever we were seeing in the Excel, how it looks in Tableau. So you have all the types of movies. Then for example, I drag the release year. Now first, I do not want to consider it as a dimension, so I'll just release year, per category, per type, there is a release year, and then I'll drop the listed in. So now these are the categories, so per year, the details of the categories, right? And then you can drag the title and the associated rating. So this is just a view of your data. We can name it as shows listing report. Now let's try to create some report for some measures, some numbers, etc. So now let's check in which country how many movies or titles were released. What is the count? So first let's drag the country. So as soon as we drag the country field, it has identified that it has the geographical names and identified the latitude and longitude details. So Tableau internally does that automatically, and it has identified the spots across the globe of the relevant country. Now let's drag the listed in on the color section. Now what it is doing is, it is showing in which country what different kind of category wise movies are or shows are being released. Like in Sri Lanka, documentaries have been released. In India, action and adventure. United States, action and adventure, like this. Now let's put a count of the titles, right? So if you see 247 action and adventure movies or shows have been released in United States. Okay, so this is one inference by this particular report you can identify. So let's save this report as listed in by country. Okay, now let's create another report. We will call it as the per year statistical report. In this, first I'll put the release years in the column. Now count of Netflix titles. So this is the count of Netflix titles per year. So 2017, 2016, 14. And then count of Netflix titles in the countries. This is the second bar chart. Okay. Now what I'll do is I'll combine it into one. So one report we are moving in the bar, creating the bar, and one in the line. And now I just have to, so we will click on the count of Netflix titles by country, right click, mark it dual axis. So now as soon as you click this, both the charts have been combined, and right click over here and say synchronize axis. Okay. Okay. So now if you can see right, in 2017, you had 2,303 Netflix releases across all categories and 1159 titles, right? 1063 titles in 2017. So this is a descending representation of the count of titles released per year across category and across titles. So let's call this as per year stats. Now let's create another report. Number of shows per title, okay? So, or sorry, per rating. So we will drag the rating column and we will count of titles and unique count of titles and unique count of show IDs. Okay. One is bar and one is line. Okay. So this is a report which shows rating wise titles and the show IDs. So in the tooltip, you can see the distinct count of titles and show ID per rating. Okay, so let's call it shows per rating. Now let's create another sheet, call it as shows by cast. So in this, what we're going to do is first drag the cast column on the rows section. You have name of all the cast, and then we drag the show ID on the column section and put a count D and sort it. Okay. You can remove the null cast, and this is your sorted order. And on the labels section, you can say show mark labels, and you will see the count that Anupam Kher has done the maximum, then Shah Rukh Khan, Om Puri, Nasruddin Shah. So this is the details on the sorted order, that who has done how many shows. Okay. Then next is shows by director, similar to shows by cast. Drag director into rows, or differently if you want to prepare, into columns, and then count of show ID, okay, sort it, and you can actually filter out the null director value. And this is your count. Put the label So you can see Jan's sweater has the maximum shows. Okay. Then create another report, shows by category. Now similarly drag the listed in the rows and show ID count. Remove the null category and sort. Labels, show mark labels. So international movies are the highest category, dramas the next, comedy, international TV shows. This way you have your category. Now let's create a dashboard in which we want to combine all these reports and take a common view. So first let's drag listed in by country, then shows by director. Also please let's set the size as automatic. Then let's drag shows by category and shows by cast. Now these 4 reports are on a single dashboard. We will link them to each other. So go to worksheet, actions, add action, filter, select dashboard 1, only select shows by category here, and in target dashboard 1 except shows by category keep everything else, and in the source sheet just select, click OK. Now whatever category you will select over here, that related category data will automatically be shown in other reports, like see international movies across the globe, across the countries, directors of only international movies, who has done the maximum, Johnny To, and shows by cast, right, that who has done the maximum international movies or dramas or comedies. See, Paresh Rawal has the maximum number of comedies, and then if you see the comedy movies, these are the count of comedy movies released across the countries and who is the director. Another very interesting report which you can prepare is that, for example, you want to check in which country maximum duration of your movies have been released. So first let's create convert to measure, remove this. Okay. So if you see, maximum duration of the movies or the entire Netflix content is maximum in United States, then in India these many minutes, next is United Kingdom, and you can also change the colors. Whatever you feel is as per your standards or as per the convention, you can change the color combination. So there are multiple ways you can generate reports, and hope you have understood how you can leverage such a data to create your reports. So let's discuss what's in it for us today. Now we will first talk about why Power BI, why it's a popular tool and what problem it solves. what is Power BI, and what are the primary features of Power BI, which you can use in your day-to-day data analytics, visualizations, creating fancy reports, creating meaningful, intelligent reports for your organization, for your personal use, for crunching numbers, for generating reports real time, etc. Now, the most popular tool for Power BI is the Power BI desktop. I'll show you certain aspects of Power BI desktop, and then I'll show you the steps how to install Power BI desktop on your machine. And then definitely Power BI desktop is a free tool provided by Microsoft, but then you can also subscribe for an enterprise version, which is primarily used by enterprises for publishing their data. So we'll see the difference, and then overview of dashboards which can be created. What kind of dashboards can be created in Power BI. So this is the agenda for us today. Now, why Power BI? So generally, visualization tools, reporting tools are required in order to create and prepare and analyze meaningful data. It could be a data for an organization. It could be a social media platform data. It could be a data from IoT devices, but something which needs to be analyzed, and some intelligent inferences and data mining has to be done on top of it. Now imagine today we are in a world where terabytes of data and information is getting generated on an instantaneous basis, on minute by minute basis. So it becomes very essential to churn out something meaningful, something intelligent out of it. In the market, there are a lot of other tools which are available, like Clix, Alteryx, Tableau, and Power BI. So Power BI is a Microsoft product, which is one of the most popular products, and it comes as a free to download product, Microsoft Power BI desktop, which is available, and I'll show you a couple of ways how you can install it on your machine. But why Power BI is popular is because it provides a lot of out-of-the-box features, drag and drop features, which we will talk about in our subsequent sessions and classes. But today's session is primarily focused on giving you guys an introduction on what is the purpose of Power BI and what all problems it solves in the real world. So Power BI allows you to view, analyze, and visualize huge quantities of data, and the data could be in any format: Excel, CSV, text, or it could be a direct connection to a database like SQL, MySQL, Azure, Oracle, anyone, IBM DB2. So it supports n number of data types or data sets, and it's very powerful in terms of data connectivity. So it uses powerful compression algorithms to import and cache the data within the .pbix file. So it's as convenient as a simple software. If suppose you import a data and then you prepare a report, and then you can easily share the reports with your peers or someone who's co-developing with you, either through Power BI cloud services, or even you can share the PBIX file in an email or through any other means, and you can share the data set with the concerned, and they can then work on the report independently. So there are different ways. There is no kind of a limitation for working on Power BI. There are multiple ways, and it is very fast. It is the most fast tool to work with Excel, because definitely Excel is also a Microsoft technology, so it works very fast on Excel based data and gives you numbers and reporting at a very high speed. So now once you have imported the data, Power BI allows you to model the data, allows you to work intelligently on the data. It allows you to model the data in a way that if you are importing data from multiple Excel sheets, importing data from multiple tables, you can easily create a relationship between those tables or data sets in Power BI, and then create visually appealing reports, meaningful reports, as I've been emphasizing, and make sense out of that data. No data in silos is of any use. Data in silo means a single worksheet or a single data set will not churn out any meaningful information until and unless you basically join it, club it, merge it, union it, append it with some other data sets, because a single data set will never be able to hold that much amount of information which is generally required for a important report. So it has easy drag and drop functionality with features that allow you to copy all formatting across similar visualizations. So just like in Microsoft Excel we use Format Painter to copy the format of one cell to another, similar features, very similar to Excel products or Microsoft products, they have provided that if you have applied a particular theme on a report, you can easily replicate that on any other report. The font, the header size, the background color, you don't need to do it again and again. So there's lot of reusable features which are also available. Okay, now as I said, Excel is a Microsoft product, Power BI is a Microsoft product, so they have intercompatibility. You can publish data from Excel to Power BI. Now with the latest developments and enhancements, as of today, Excel has also plugged in a new feature called Power Pivot, which I'll show you later down the line. But that also allows you to do a quick analysis. You can't create, of course, complex reports or fancy reports like Power BI, but Power Pivot allows you to create, quick measures, quick functions, quick calculations on your data quickly only in Excel. So it's an Excel plugin. But whereas, Power BI is also compatible with Excel. So when you create a report in Power BI, it gives you inbuilt feature to export your Power BI report into Excel format directly. You don't need to do any programming for it. Also, you can easily publish, when you publish your Power BI reports, it allows you to give some inbuilt intelligence of analyzing your reports in Excel, and it gives you all those features of exporting your Power BI reports into Excel, which is not available in any other tool, or otherwise those tools have to create plugins, create add-ins, and probably they might charge for it. But Power BI comes with a lot of out-of-the-box features which are very, very helpful for analyzing data in Excel, and vice versa. Azure Cloud. Now Azure itself again is a Microsoft Cloud tech stack. So using Power BI with Azure allows you to analyze and share large volumes of data. So Azure, basically Azure database or Azure cloud servers are meant to hold huge amount of data, and Power BI allows you to have seamless connection. You can easily connect to Azure Data Lake. You can reduce the time it takes to get insights and increase collaboration between business analysts, data engineers, and data scientists. So Azure Data Lake becomes the central focal point where all your analysts, engineers can keep working on the centralized piece of data and churn out their reports. Data scientists' primarily job is to keep the data in a structured way, optimized way, optimize the input-output operations, disk operations, and memory utilization, so that the reports also get churned out in a faster manner. So every person has their own role in order to give a quick refreshable report, a quick rendered report. Any report which is taking huge amount of time to get rendered will not eventually be used by the business users, because then it does not solve the purpose. The report should be fast. Report should have appropriate filters, slices and dices. You should be able to create the reports or dynamically, or you should be able to visualize the data dynamically. So all those visualization features are available in Power BI, and it works seamlessly. Either it is small data or huge data. It allows that you to work on those kind of data in a seamless fashion. Right. So this is just a very quick example of how a typical dashboard looks like. Dashboard is nothing but, you have clubbed a couple of multiple reports on a single page, and if you change a filter a single filter on the page, all the reports will honor that filter and the numbers will change accordingly. So if you see in this example, there is a filter or a drop down of product ID, product name, employee name, or supervisor, or a date range. So whatever date range or filter you will apply, all the reports on this dashboard will get changed based on the filter you have selected. So Power BI allows you to get insights from data and turn insights into action to take data-driven business decision. And that is the ultimate goal of any visualization tool. That is the purpose for which visualization tools are bought and purchased by the organizations, and data is fed into them. Now, Power BI fetches data from factory sensors, social media sources to get access to real-time analytics so that you are always ready to make timely business decisions. So basically, there is a feature of live connection or cutoff data connection. So either you can work on data which is residing on a machine and you can just work on the cutoff data. Like for example, there's a data which is available for sales 2017, 2018. And you're just working on a historical data, it's a cutoff data. Or it could be possible that you want to be connected live to a real-time IoT based, sensor based data, or social media data like Twitter, Facebook feeds, or you're connected to live Google worksheets. That is also possible. You just need to publish your Google sheet for a public domain, embed the URL into Power BI, and then whoever updates that Google sheet, automatically the Power BI report will also start honoring and consuming the new data which is added in the Google Sheet. So all those kind of real-time streaming analytics is also possible, and that is one big feature and very important feature of Power BI, which is widely used and has a very huge market acceptance and market utilization. Now, what is Power BI? Power BI is a business analytics service provided by Microsoft that lets you visualize your data and share insights, right? So earlier, Microsoft used to have a technology called SSAS. Now they have replaced actually SSAS and SSRS with Power BI. So basically, you can use Power BI on the data which is there in your Excel or any other data source. And the Power BI service or Power BI desktop basically creates a connection to those data sets and import it, cache it, and give you a handle to it in order to work with it. So you can create these fancy, meaningful visualizations. Like for example, there is a geographical map. If you are importing data for a country or a continent or a region, Power BI will automatically detect that it's a geographical information and give you a map with latitude, longitude information, and you just need to plot your numbers on the map. Either you can use bubbles or either you can use triangles or whatever data structure you want to use, but all the mapping will be available geographically. Then you can create pie charts, which is shown in this visualization. You can create tree maps. You can create cards where you can highlight the most important numbers like sales, total sales of your company across all the regions, or the growth chart, or the month on month sales of your organization, or total number of products or units sold. So whatever is important and to be highlighted for the management to take any meaningful decision or any insights you want to share, Power BI visualization tool, the Power BI visualization chart allows you to drag and drop and create wonderful reports. Okay. So what are the features of Power BI? So Power BI desktop is something, a standalone tool which you need to install on your machine. It allows you to build reports by accessing data easily. You do not need advanced report designing or query skills to build a report. Though yes, it is beneficial that if you know some SQL programming, analytical programming, or you are aware of advanced features of any analytical tool, that might help you, but that's not a showstopper. You can easily build reports in quick turnaround time without
needing any technical background. You just need to have some analytical mindset, and you can create savvy visualization and analytical reports. Stream analytics, as I mentioned, you can create a live connection with any kind of data. It could be IoT, it could be media, social media, it could be Google Docs, it could be any other kind of live connection. It could be a live database connection itself. So any insertions or updations or deletions happening will automatically reflect in your report. Yes, multiple data sources, and that has to be the primary criteria for any tool to be popular. If any visualization tool is limited to certain data sets, then it will not be highly acceptable in the market. And custom visualizations, right? So as I showed you certain examples in the past, in the previous presentation, that feature is very important because someone might want to look at the KPIs from a different perspective. Some management might want to look at the KPIs from a different perspective. So you need to have that capability to create different visualization from the same data set. Now let's take a look at how to install Power BI desktop on your machine. So basically what you need to do is you need to go to this URL, powerbi.microsoft.com ENUS desktop, okay, and you need to just enter this. Now you can download it for free, so just click over here and it will open Microsoft Store. So basically now what Microsoft have done in the latest operating systems is that when you are trying to download, you can actually directly go to the Microsoft Store and search for Power BI. So let's wait for a couple of seconds. Right here. So Power BI desktop in Microsoft Store. For me, it's already installed, so it's asking me to open it. I'll open it in a while, but for anyone who is not installed, he will see the button of install over here, and it will automatically install in your machine, and then you can easily go and open Power BI desktop. Now if I click open over here, now this is the UI of the Power BI desktop. I'm not going to go right now in creating reports right away. We will talk about that in a subsequent session with sample data sets, and we will cover the features of Power BI desktop one by one. But this is what it is. This is the whole tool of Power BI, which is having the visualization pane. All the different visualizations are can be created from this pane. Then this is the pane which allows you to select the data fields. Then there is a report view, data view, and relationship view, the data model view, where multiple relationships you can create. You can view the data in the grid of the tables which you will create, and the reports. So you can create multiple reports on multiple pages. You can keep adding pages. Either you can create multiple reports on a single page and it will become a dashboard, or you can create separate independent reports on the single page. And these are the menu options which we will talk about. How you can change color scheming, you can do data modeling, you can create new reports, and you can also transform data, which is the biggest feature. Extract, transform, and load the data, apply different logic, changing data types, massaging the information, creating new joins, appending the data, adding new columns, etc., etc. That is what you can do in transform data. So this itself is a whole different world. It's a dedicated topic. So we will talk about that in our subsequent sessions.
So what's in it for us today? We will be learning how to connect to data, different data types, data files like Excel, PDF, then what are the different data importing modes, and then I will also show you practically different sets, how to import them in Power BI and use it for your visualization purpose. Now, what are the steps to connect to data? So now we will go directly into Power BI and try to import one by one few most commonly and popularly used data sets which are most commonly used in a day-to-day activity. Rest, of course, there are Power BI supports n number of data sources, but we will do something practical on the most popular ones. So let's open our Power BI. Now this is my Power BI, and first I want to show you that how can I import data directly from a web page and import the data. Now it is asking for a URL in order to import data. So what I have done is I have created a Google Excel sheet with simple data with rows and columns, and what I have done is I have shared this sheet as published to web. Okay, so you just need to say publish to the web, the link as web page, and say done. It's automatically published, and say link. So copy the link which you have published on the web, copy this link, and then go back to your Tableau, paste that link over here and click OK. Now Power BI will try to establish a connection with this Google Doc sheet because it's published on the web. You need to wait for a while it is reading. Okay, now it has read one of the HTML tables, so I'll select this one. Now you can see it is showing me a preview of the table which is there on my Google sheet, right? It has 11 rows, so it has all showed all the 11 rows. So now I can go and transform this data because I can see my headers are there starting from the second row. So there is an opportunity for me to transform the data. So I'll go and transform it so that it looks clean. Okay, so first is I need to remove the first row, which is the null row. Remove the top rows. Okay, and then I need to use the first row now as a header. So you just click this option, use first row as headers. That's it. So now if you see my row ID, order date, ship date, all my data is now ready. So I can say close and apply. Click apply changes. Now this is an example of web data import. You can go and preview your data. Right now, the biggest advantage of this data connection is that it's a live data. So for example, I insert another row. Let me change the order ID. I've changed some basic stuff, and it's auto saved. Control S. Now I'll go to my Tableau and I'll refresh. Now you can see as I refreshed my Power Query Editor, I clicked refresh all and I got my new row which is there in the live data. I got that fetched from my okay, I got that row, the row ID number 12. So I have to say close and apply. Now you can see the new row, the row number 12 is now available in my new data set, in the data set, because it's a live connection. It's a live connection with the web-based Google Sheet. Okay, so this is one important way in which you can import data. Now let's try to import data from a text file. Now I have already prepared a text file called subcategories.txt. Now let me just open it in a notepad. Now it's a very plain simple file, tab separated file in which you have product subcategory ID, subcategory name and product category key. So basically to which product category this particular subproduct belongs to, right? So what I'm going to do is I'm going to go back to my get data option and I'm going to select text/CSV option and I'm going to select option mod product subcategories.txt. Okay, so now Power BI has identified that it's a tab delimited file, it has recognized the headers, etc. right, and I can now directly load this file. Okay, so now once the data is imported in Power BI, it is like irrelevant to me, it's a composite data import I am doing, right? So in my presentation, when I am talking about importing data, there are different importing modes, right? Data import can happen through different ways. Okay, one is direct query mode, in which I create a live connection to the database, which I'll also show you using MySQL and MS SQL Server. And also you can do a composite mode in which you can have data imported from Excel, plus you can have direct query modes. So you can have multiple modes to connect and create a composite data model, and that's what we are doing right now in our practical. So what we are doing over here is, one, we have imported data from the web. Second, we have imported data from a text table. Now after doing text, now our next task is to import from CSV. Let's try another one. So now I have imported product subcategory. Now I'll import a CSV file. So again I'll choose the option text/CSV, and now in this CSV file, let me open this CSV file and show you what is it. So this is a list of all my products, product key, product subcategory key, products stock keeping unit, etc. A simple CSV file, and I'm going to import that. Okay, so now it is identified the delimiter is comma rather than a tab, and it has already recognized the headers correctly, so I'll load it. Okay, so now my products are there, product subcategories are there. For product categories, now what I have done is I have created a Excel mode now. So now Excel I am using to import my product category. So now I have to click on the option of import data from Excel, and I'll say product categories. Select the sheet, load, and now so my products, product categories, product subcategories, though with different data storage types, but still now the data is imported into Power BI. It is a composite data model. Now another very important data type which you can import is the PDF also, right? So what I have done is I have created a PDF called customers. My customers data is lying in a PDF. So what I have done is I have created a PDF which has data for some columns are there, like, you know, customer key, prefix, first name, last name, birth date, marital status, gender, email address, annual income, total children, etc., etc. So this is the data set which I have created in PDF. So what I'm going to do is I'm going to select PDF now and import customers.pdf, and see it has recognized my table on page 1, which I'm going to load. Okay, you can rename this as PDF table.
So this basically, these are the different type of data types. We have imported PDF, Excel, text, CSV and web page. Now let's take a look at another interesting data set which we want to import is the MySQL Server data set. So what I have done is I've already installed MySQL Server on my local instance, and there's already a schema of SQL Live tutorial over there, and I have certain tables already prepared over there like department, employee, etc. So my goal is now to import this data or create a live connection with this data set. Now in order to import my SQL database connection in Power BI, you need to first download a connector, MySQL Power BI connector. So you need to go to this link and then click on download and install the MySQL connector. Based on the operating system you have, you click on download and install it. After you have done this, go back to Power BI and then give the IP address of the database. In my case, it's there in this local machine, and the schema which I want to import is SQL Live tutorial. So I'll give the name, click connect. Okay, now it's connected. So now it is asking me which particular tables you want to create a connection with. I'm choosing department and employee, and I'm just loading them. Okay, so now this is the exact data which is there in the employee and department in MySQL. Okay, so this is one example of how to create connectivity between Power BI and MySQL. Now I want to do the same thing using SQL Server, Microsoft SQL Server. So I have also installed Microsoft SQL Server on my machine, and I have used the SQL Express. So this is the name of my server, so which I'll copy the server name and go to get data, select SQL Server, and for now database is optional. I can say direct query, click OK. Okay, now it is showing me what all tables I can import. So in my SQL Server tutorial, in my SQL Server, I have these three tables: customers, employee attrition, Olympic events. So I can use probably the customers one, which is now you can see this is the data, the customers data, which is lying in my SQL Server. Okay, so I can preview it and load it. So now you can preview the data in Power BI. That this is the data. So I can rename as customers from MS SQL, and this is from MySQL, and okay. So now this is not the only data sets you can import. Now if you take a look at the options which Power BI gave of what different type and variations of data it has compatibility to import from. Okay, so we can just take a look at the categorization on the left hand side first. There are file-based like Excel, text, XML, JSON is also possible. You can evenly directly import an entire folder, and within the folder, whatever data types of files are there, it will detect it. PDF, Parquet, or even SharePoint folder, which is itself a Microsoft technology. Then different kind of databases, SQL Server and MySQL we just saw, but it's not only limited to this. You can connect to Microsoft Access, SSAS, Oracle database, IBM DB2, Postgres, Sybase, Teradata, and then SAP databases, Amazon, Redshift, Impala, Vertica, Snowflake, and n number of databases which are there in the market today, Amazon, etc. Then it also allows you to connect with its own Power platforms, Power BI platforms, data marts, Power BI data flows, Dataverse, etc. Azure, there are different kind of storage mechanisms in Azure, and Azure itself is a Microsoft technology, so it has a compatibility with a lot of Azure based data storages like Azure SQL database, blob storage, Azure Databricks, right, Azure HD Insight, Spark. So if you have those kind of services running on your Azure cloud services, you can even import them over here. Now online services, like you have ERPs running or some data which is shared on the internet. If you want to import it, that is also possible through certain products. Dynamics 365, Microsoft Exchange Online, Salesforce, Google Analytics, Adobe Analytics, GitHub, LinkedIn Sales. If you want to do some analysis of some social networking, feeds, that also you can import. Then other miscellaneous are also there, web-based, Hive, R script, Python script, if there's something to import, get data from. Google Sheets, like we saw one example in our video right now. So there are multiple options available. Now, once you have imported the data which is relevant to you, in our subsequent sessions we will see how to create relationships, but just giving you a glimpse that whatever data you are importing, Power BI auto detects certain relationships and it will create for you, but then you can go and manually also change. So this is the composite data model which is getting created in the backend while you are importing the data. You can easily go and manage these relationships, either keep them as is, you can delete and create new ones manually. So there is no limitation in that. So this is what we have witnessed. We have imported data from different files types, data types, and then we have tried to, once it is imported into Power BI, then there is no limitation of how you use it. You can create visualizations across different data sets and then create your standard reports. So this is the example of importing data from web, importing data from a database, from a PDF, and then once you have data, you can shape and combine data. You can basically do whatever transformation you want to do. You want to make joins, merge the data. So for example, if we go back to our Power BI, and if I go back to my transform data section, now as I have now different data sets available with me, I can do any kind of operation, transformation on the data, right? So like I showed you, I upgraded the header row because one of the imported data was not showing the header correctly, or this column, like this exact one column is extra, I can remove the column, right? All those transformations, whatever I do in the backend, gets captured in the applied steps section, right? This is the customer data. You can create, you can merge it, you can append it, with other data sets. right? Let's, for example, I want to create a merge data set of my categories and subcategories. So I can say merge, select these two data sets and say merge queries as new, and I can select product categories and product subcategories, select product category key on both the sides, and then they do a left auto join. So whatever product categories are there, I'll get the subcategories associated with it, and I'll create a new table which will have, now I have the table which has the category and the subcategory in one table itself. So I can rename it now to as category subcategory table. It's a merge. Basically, it's a join between category and subcategory, and now I have a common table, right? And I can close and apply. So imagine I have created a new table which is created from one data set which is Excel based, and another data set which is text based. See this category subcategory table. So now I can use it the way I want in my visualization reports. So that's what the presentation says, right? That once you have the imported data, you can shape, you can combine, you can adjust, you can do whatever transformation you want to do and create your visualization. Okay, so what topics we are going to cover today? We are going to talk about different types of data modeling, and the most important part and aspect of data modeling is the cardinality. The cardinality which you basically decide after reviewing the nature of data, and after you've imported it, what kind of cardinality you have to basically highlight, right? And there are different type of cardinalities which you might have heard earlier also if you're from PL SQL background, like 1:1, 1:many, etc. We will talk about that. Now, what are the different types of data modeling? Now, dimensional data modeling is one of the most popular and most widely used modeling. In dimensional data modeling, you have master data, like for example customer data, date, store data, product data. So these are like less frequently changing data sets. So there is an organization, right, and you have set of customers, their email ID, phone numbers, etc. that will change less frequently as compared to the sales transactions, because transactions are happening every day, every minute. So sales is a more fast changing data set in dimensional modeling, which is in the terminology of data is also called as a fact, and customer, store, product, which are like more of static data and less changeable data, is sometimes called a dimension. So this is a typical dimensional data model which is typically used sometimes, right? And then there is another model which is relational model. This is a typical model which we have been using in database design, like primary key, foreign key relationships. So for example, you have a customer who has purchased a product. So probably the customer might have the details of the product which he has purchased, and you will make a join between customer and product table, and even you can make a join between product or product type or customer or product type. So customer table will also have a key to the product type. So this is less conducive for reporting, but it is more of a transactional relational model. But of course, this is also feasible. But from the Power BI perspective, when we talk about reporting and visualization, this is the most extensively used dimensional data model, and this is what we are going to see in our example now. So what I'm going to do is I'm going to show you certain data sets. First, we will prepare and create certain of our data sets, and then we will import in our sample Power BI file, and then slowly we will create the relationships. Now, one important thing which you need to understand, that in Power BI, if you go to Power BI, there is an option that Power BI auto detect new relationships after data is loaded and import relations from the data source on first load.
So for example, if you are importing the data from a database where you have already defined the primary keys and the foreign key relationships, so that is the first option which Power BI will auto detect. And secondly, if suppose you are importing two different kind of data sets, one is Excel, one is CSV, and if Power BI detects a common column, key columns, it will auto detect a relationship which you can go and later change, modify, manage in your relationship menu, manage relationship menu in Power BI, which I'm going to show you. Okay, so if I open a Power BI, and this is where the option lies, go to File, go to Options and Setting, Options, Data Load, and these are the two options which are by default checked. You can uncheck it and manually prepare relationships. There's no limitation to that, but if you keep it checked, then Power BI will do its job to detect the relationships. Okay. Now coming to the next important factor, cardinality. Now before I start playing around with my data and start showing you certain relationships, it's very important to understand these four types of cardinalities. One is many to one, right? So basically many to one means that many orders contain data of one customer. So per order, one customer is there. So from customer to order or product or delivery address, it's a one-to-many relationship. And from the other side, from order to customer perspective, it's a many-to-one relationship. Okay. Second, other cardinality is 1:1. 1:1 relationship is only applicable when you are saying it's an extension of the current table. So for example, in one table you have employee details and you are extending the details of the employee in another table like employee address, employee ID. So that is like 1:1. There is no multiple records of a single employee. In the address table, only one employee ID exists, right? Now 1:many, as I said, is the reverse side of many:1. So in customer table, only one customer record exists per customer, and one customer can place many orders for multiple products and can also have multiple delivery addresses. So that way, this is a typical 1:many relationship. We will be seeing this example also in our sample data set. And last is the many-to-many relationship. Now, many-to-many is a very typical example, so which I'm going to show you practically. And in our case, we will see that, like for example, you have placed an order for a particular product, but there are multiple fulfillments which has happened. So suppose you made order for 10 products, but at the back end, when the company is fulfilling, it is first fulfilling the first 2 products, then the rest 3. So basically the fulfillment is happening in batches. So one order ID might have multiple fulfillments for the same order ID. So there will be a many-to-many relationship, which I'll show you practically. So now with this background, let's start importing our data. Now the first important thing which we need to import is the master data. So first I'll import all my master dimensions which I'm going to use in my example. So first is the customers table, customers data. So this is the customer details, the customer key, prefix, first name, last name, birth date, marital status and gender. Some redundant columns are also present, but we'll remove it. So my customer data is loaded. Now today's session is all about this section of modeling. So we will keep our focus over here. Okay. Now some columns, probably some blank columns are there. I can select them and say delete from model. Yes. Okay. So now this is my customers data with the relevant columns and the key per customer, customer key.
Now there's no relationship in this model right now, right? Because only single table is there and the associate data is only imported. Now let me also import my another important master table is the products. Select the product data, product key, product subcategory, product SKU, product name, model name, product description, color, size. So just see all the relevant information only specific to the product is available. So I'll import it. Okay. Now see, there's no relationship between product and customers directly, because until unless a customer makes an order, places an order for a particular product, there is no join, right? So now between these two tables, the most important, now another table which will now make sense is the sales order table, sales table. Now I am assuming that Power BI have auto detected the relationship. Now you can see that because I've already ticked that checkbox. Now let's see what relations Power BI has auto detected. Let's first check the relation between customer and sales. I'll double click this join. Now what it has done is it has created a join of many to one between sales and customer. So what does that mean is that one customer can place many orders, right? And that it has detected by the quality of the data and the data sampling which Power BI has done. You can also reverse this relationship. Here I can select customers and I can select sales. Now it has become one to many. So that you can also do manually. So that is what I said. Whatever Power BI is detected, it is up to the discretion of Power BI internal configuration and algorithm, but you can go and change it. So this is now you can make, this is by default active, so we want to keep it active. One customer, many sales orders. Cross filter direction means that only from customers to sales is the filter applicable, not reverse. I'll come to this with my another example, but first let's change the relationship. So 1:many means from one customer and many sales orders. Similarly, let's see what has happened at the product side of the relationship. Similarly, Power BI, many sales orders for one product. You can, for simplicity's sake, you can say products, sales, product key is the join. Now just focus one more thing. Please also see the column on which the join is the grade column, grade out column. Product key is also here and product key is also there, and it is what we wanted. So 1:many relationship from product to sales table and active. Now looks fine. This is something which is looking logical, and probably now we can proceed further to create a report. Now let me explain the cross filtering with an example. Now, for example, I want to check in a report that what is the count of products which a particular customer has ordered. Okay, so what I'll do is I'll select the product count of product name. Now if you see, and for each customer, in front of each customer name, the count is coming as 293. It is getting repetitive because there is a one-way filter direction filter between customers and sales and products, right? So this join is single-sided. It means that from customer to product you can't find a relationship because it's a single side cross filter, right? What does this, if I change it to both, it means that it is equal to a join between product and sales, and every product detail now is appended to the sales table. So if I want to make you visualize this, you need to go here. I'll first open my sales table.
we can also open it here. Let's make click this OK. Now if I click OK, you can see the single arrow is changed to double arrow. It means it's a both side filter. So when you say a both side filter, it means that implicitly within Power BI, you can imagine that all the product columns now will get appended because of both ways filter you have applied. And if you go to your report now, see the change of the numbers now 40, 20. So the total count of products across all my customers come out to be 293. Now the report looks correct. If I change the relationship from back to single between product and sales, then you can't make a join between customers and product. Basically, you can't derive the product count from the product table. See this. If you have to live with it, then you would have to go to the sales table, get the product key and get the value of count of product key, but that is not correct. Okay. So if you want a report in which you want the count of product name, and even if you want a count of distinct product name, so this will not come correctly. You would have to go and change the direction of the filter, which is from single to both. So this is a typical example there where you want to use a two-directional filter. Now let's proceed further and import other data set in order to show you another example. Now I want to show you an example of 1:1. So I have another table which is called customer details. So the key in this table is again customer key, but only email address, annual income, total children, education level, etc. Other details of the customer is there. So I'm loading the customer details. Now you see it has auto detected a 1:1 relationship. Now what is the meaning of 1:1? Means one customer key only has one entry in customer details. There is no multiple entry. So if you click this button, it's a 1:1 and the cross filter can be both or single, doesn't matter, because one customer will have only one value. You can make this as active. Okay. And if you go to the customer report table, you can now easily associate a email address with the first name. You will get 1:1 record. So now you can see that with 1:1 relationship, with the first name, I have associated the email ID, and for each email ID, there is a associated first name with that. So this is an example of 1:1 relationship. So in this example, what we have explained is that for each customer, there is an associated customer detail, right? So you have the first name, email address, education level, homeowner, occupation, and total children count. So in this report, what we have done is, if you click over here, so the first name and the email address. Okay. So there's a 1:1 relationship, and if you drag the customer key, report takes time to render, and even if you can, so this is the reporting output. You have the customer key, first name, associated email address, and the count of product names which the customer has ordered. Now this is an example of 1:1. Now I want to show you an example of many to many. Now for that, I'll import my fulfillment data set. Okay, now in my fulfillment data set, there is a column for order number. So basically what I'll do is I'll drag order number from here to here. Okay, so now what has Power BI detected? I'll do one thing. I'll select sales over here, fulfillment over here, and order number to order number. Okay, so it's a many-to-many relationship. So it means that per order I have created multiple batches to fulfill that particular order. Now many-to-many relationship is definitely a candidate for both ways cross filter detection direction, but you can check that. But definitely Power BI shows a warning that this relationship has cardinality to many, and this should only be used if it is expected that neither column contains unique values. Okay, so we know that fact. That's why we are accepting this relationship as many-to-many, because we know there are multiple order numbers over here in the sales table which are mapped to the multiple order numbers in the fulfillment table. We'll click OK. Now you want to keep the direction as both ways or one direction. That is up to you, the way you want to map the report. So I can double click over here, and you can even click. So now you can select from which way single filter you want, from fulfillment to sales or sales to fulfillment. I'll prefer sales to fulfillment and click OK. Okay, now we have all our different kind of relationships over here, which we have tried to shortlist. One to many, many to one, one to one, which is this example, and many to many. Now if I show you further relationships which you can keep on adding, like for example I have the example of territories. Now in which particular territory the sales was done, so I can map it over here. Okay, so now it's a typical 1:many relationship, because territory is my master table where I have a static list of continent, country, region, and it is mapped to the territories which are in which my orders have been placed. So it's a typical 1:many. So that way, you can keep on adding data. Then you have details of returns. Now this is another transactional table which is about the orders which have been returned rather than being returned by the customers. So you have a product key, so automatically Power BI has detected a relationship between the product key and the product table, right? And even if you can join the territory key, in which territory the return has happened, right? So mostly the most common relationship which you will observe is the 1:many, because as I told earlier, the most common relational model is the dimensional model. The static data, the slow changing dimensions, the SCDs are the master tables, and the most frequent changing are the fact tables. So if I talk about a typical dimensional model, the fulfillment table, sales table, and the territories table, the fulfillment table, sales table, and my returns table are the fact tables of my data model. Now so far what we have done as per our last session is that we did data modeling on the different data sets which we had imported in Power BI, like products, sales data, returns, fulfillment, customer details, and customer master data, calendar details, etc. So in the last session we prepared a data model and established the relationships between these different data sets, like 1:1, 1:many, many to one, 1:1, etc. And we saw the examples. Now once our relational model is prepared, our data model is prepared, now our next activity is to create certain additional columns which we want to derive basis the data which we have imported. So for example, I'll start with my product data set. Now in my product data set, I want to introduce a column which basically categorizes that if any product which has a color red, black or gray, I am going to tag it as a colored product. Rest I'm going to say not a colored product, right? So all these are like example of byte type product SKUs. So for that, now in order to introduce a new column, you just need to do what? You need to select the table in the data grid, go to the table tools and say new column. Okay, so column will get appended to the rightmost part and you will start seeing a formula section typical to like you get in your Excel. Now I'm going to say that the name of my column is going to be byte type color. Okay, and I'm just creating a if condition. If product color is equal to black, okay, or if it is equal to red, or if it is equal to gray, then say yes, it's a colored product, else say no. Okay, so now you can see basis the product color red and black, they are saying byte type color yes, blue is no, multi is no, etc, etc. So this is a classic example of an if and else condition based conditional column. Okay, so you can create such columns. Now second column, custom column which I want to create is I'm going to call as discount. Now basis the pricing of my products, I want to associate certain discounts which I am ready to give to my customers basis the product category, like what is the pricing of the category. Again I'm going to make use of if else, but in a nested way. So if I am saying if my product price is less than 100, then I will give 0% of 0% of discount. So 0 into product price, just to keep it consistent. Now I'm saying else, if less than 100 then 0, else I'll check again that if the price is less than 500, then I'm ready to give 1% discount on the product price, else I'll move further. So like this, I have created a formula. So what I'm saying is if product price is less than 100, give 0%. If it is less than 500, then give 1%. Less than 2000, then 1.5%. Less than 3000, then 2%. And otherwise, else less than 3000, if it 2%, else 3%, right? Now after this column is created, now you can check, right? So this, see, the product price for this particular product, it is less than 100, so that's why there is no discount. It is between 100 to 200, then this has been given a 1% discount. So like this, all the discount column is now calculated. Now this column is available just like a regular column in my product table. Now after this, I'll go to my sales table. Now in sales table, I want to identify create a column called as cost. There is no product cost column over here, so that will be derived. So let's create a column called as cost, and it is derived by order quantity into, now the cost of the product is in the product table, and I know I've already created a relationship between product and sales table. So I just need to select the product cost column. Now only keyword which I have to use in Power BI is the related keyword. So this will pick up the relation, and now for this particular sale order, the cost has already been derived. So this order number, this is the cost for which the product is the costing of the product for this particular order. Okay. Now I'm going to create another conditional column over here called as order status. I'm saying if any order whose order quantity is greater than 2, then for my organization it's an urgent order, else it is a normal order. Oh, sorry, I lost it. So this is my order status column, and I have my order quantity, urgent or normal. So any order which has order quantity 1 is normal. Any order which is having order quantity as greater than 2 is urgent. You can see this. So there's this whole Power BI tabs and sheets allow you to also review the data, what you're doing. So it's very convenient. Now I have my sales data. Now what I want to bring within the sales is my discount column. So here also I want to bring the discount which I have created. So I'll say discount. Discount will be order quantity into related product discount, right? So the discount calculated column which I had created under products, I'll bring over here. Now I am creating the order level discount. So if you see, for this particular order, there's a 25 for 25 rupee discount at the cost is 100,000 rupees. Okay. And what is the order price now? So I have taken the order cost, the discount. Now I have to create a column called as price, order price. So that will be again order quantity into related price, which is per product price, enter. Okay, so now I have the cost, the discount and the price, right, available with me. Now I want to calculate the total revenue, total profit and loss, right? Per order, how much so first I'll calculate per order how much revenue I am generating. So now I have to generate a column called as revenue. Revenue is price minus discount so 1700 minus 25, 1700 minus 25, 2071 minus 42. And if I want to calculate the profit per order, then it is revenue minus cost. Okay, so now you can see, typical custom columns, calculated columns which we have created are all playing around with the numeric values, numeric data primarily, and trying to give inferences into per order cost, discount, per order price, revenue, and profit. So typical calculation columns which I have prepared in front of you. Now let's take a look at other different variations of custom columns. I'll create certain columns for text-based custom columns, calculated columns, using text-based data. So I'm now moving towards my customer table, in which I have customer key, prefix, first name, last name, birth date, marital status, and gender. Now I want to create a new column in which I want to derive the age of each customer as of today, right? So I'll use another function, a date function called as date diff. Now date diff, so I want the difference between the birth date of the customer and as of today in years. Okay, so this customer as of today is 68-year-old, one is 74, 68, 57, etc. So this is one derivation of a calculated column of age. Let's take another example. Now this is a text-based column where I want to derive the full name of the customer. Now here I'll say first lowercase, in lowercase I'll concatenate the prefix, then ampersand, space, ampersand, first name, ampersand, space, ampersand, last name, and closing brackets, etc. Full name. Okay, so this is an example of full name in lower cases. Now another calculated column, conditional column at the customer level. I want to identify a flag which says who is my target customer. basis the demographics shared over here. Target customer. So I'll say if the marital status is equal to M and total children, and total children annual income. So okay, so let me change the logic a bit. So marital status is M and age is less than 50. These customers are my target customers. Okay, so I would say yes, else no. See this. His marital status is married, Logan Diaz, and age is less than 50, else everyone. So if I try to filter, so these are my target customers. 69 out of 1178. So this is just a conditional column, but a logical condition, an example which I'm trying to highlight over here. Okay, now let's look at certain calendar date oriented columns, calculated columns. Very typical, like now I have a simple date column. Now I'll keep adding certain columns which which will help you understand how you can do some calculations on the dates. So like for example, I want a date which is 12 days after the current date, the date in the column. So just simple 12 days after, select the date and add 12. Now if you see the date format, you can go and change the format at the top, and if whatever you feel like this. Now see, 12 days after 1st Jan 2015 is 13 Jan 2005. You can go and change the format and other details. Let me also show you, if I go to my cost and other columns, I can go and change the format. This is like a currency, cost is currency. So I can go and change the currency type, and you can even show the dollar value or whatever currency type it is. So for numbers, you can do currency, or text or dates, you can select the format. So this is available at the column tools level. Now in customers, like we had our column of full name. So now what all things are available? Format as text, okay, data type text. So very minimal options are there. With date, you have options of the date format. Now next, I want a column which defines the expiry date. Okay, so 8 months prior to the expiry date which is coming up in 8 months. So I'll create a column called as 8 months expiry, and then there is a eDate function. I'll use that. I'll use my date in the data set, comma, I'll say 8. So now this date column will append 8 months to my actual date, and again I can go and change the format. Correct? Now another important column, like I want to know the date name. So I'll use a function called as format, and I'll select my calendar date column and I'll say give me the DDDD format of it. So it will give me the day name, the day name of on that particular date. Next, years in between. So I want the years in between the today's date and the date of my calendar. So equal to date diff, the calendar date, comma today, comma year, end. 7 years, 2015 to 2022. Then last date of the month. So if I want what is the last date of this particular calendar month, I will use a function EO month, which is there available in the Power BI. So I'll say last date of the month equal to EO month. Then just select the calendar CSV date, comma 0 in months, and enter. Change the format. Then similarly, start of the month. So I'll use a function called start of month. So for all January dates, end of the month is 31st Jan and start of the month will remain 1st of Jan. Change the format. Next, I want to know what is the week number of that particular date. So now there is an inbuilt function called week number, week num, and just pass the date and you will get the week number. First week of the year, second week of the year, etc. Now another very good example is whether the week day is a weekday or a weekend, right? So what is it? It's a week type. Okay. So I'll put a if condition and there is a function called weekday and I'll pass the calendar. If it is less than 6, it means it's a weekday, else it's a weekend. So all Saturday and Sunday day names will come as weekends, or else everything else will come as weekday. So these are very different variations of different column types, calculated columns, which is a very important utility, and any Power BI project you will definitely be ending up creating n number of calculated columns to derive your numbers, to prepare your reports. But it's important to understand what all things we can do. Yes, there are n number of functions available in Power BI, but what I have tried to showcase over here is some important functions but basis your utility, basis your problem statement, you can look up for a relevant function in the Power BI dictionary. Now, with this introduction to calculated column, this is the base for us to now get into our next session. We will be talking about creating DAX measures and DAX functions. We will be using Power BI DAX functions, which is much more powerful than simple calculated columns, where you can do more complex calculations. You can calculate totals and then use them in the reports. So for that, we will look up into our next session.
Let's embark on this transformative adventure together. Having said that, if you're an aspiring business analyst looking for online training and certifications from prestigious universities and in collaboration with leading experts, then search no more. Simplilearn's postgraduate program in business analysis from Purdue University in collaboration with Amazon, Google and Microsoft should be a right option. For more details, use the link in the description box below. We have reached the end of this session on full business analytics course. Should you need any assistance, PPT, project code and other resources used in this session, please let us know in the comment section below and a team of experts will be happy to help you as soon as possible. Until next time, thank you and keep learning. Stay tuned for more from Simplilearn.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.